What's up, goobers? Oh wait, why do I have my, hold on. I still have my Stream Deck view showing up in the corner. Let me go turn that off. Office Direct Feed Scene. Okay, there we go. Alright, what's up, goobers? Hopefully, okay, yeah, that looks like it's fixed. So yeah, it's been a pretty busy, week for me. Let me go mute this real quick. Yeah, it's been a pretty busy weekend, I guess, for me. What happened? Okay, so yeah, last weekend it was Friendsgiving. Went up to around the Dallas area, and Friday was just doing Friendsgiving, and made like 150 rolls of lumpia, and that was fun. But I think that's what I spent like all of Thursday doing also, which is why I skipped the Thursday stream, I think. Did I skip it on Thursday? No, I think I actually did my Thursday stream, but I like ended it pretty quickly because I had stuff to do, and I was also shopping for those ingredients like on Tuesday. So yeah, that was a lot of work, and this week is also kind of looking just as busy since like Thursday is Thanksgiving, and then Friday is the Texas A&M versus UT football game. So yeah, that's gonna be really important for me to watch. And then on Saturday I have Thanksgiving again with my family in San Antonio. So yeah, it's gonna be pretty busy. I'm not sure what my stream's gonna look like. My stream schedule is going to look like for the rest of the week. Hoping to do a longer form like project stream on Sunday. Haven't decided what that is entirely yet. That's why I haven't posted the what's it called? The schedule yet. But oh, hi Force Nova. Yeah, I haven't decided what my schedule is yet, so I haven't posted the schedule. Like, I only thought of this stream, like, a couple hours ago. Otherwise, I would have posted this stuff a lot earlier. But, yeah, so what happened last weekend? So we did something called Planathon, which is where you, like, rent out an Airbnb and you have, like, a bunch of builders. And, in 24 hours... we have to, from scratch, build a plastic ant in 24 hours, and that includes your sleep time and stuff like that. And then at the end of those 24 hours, we fight them. And we also need to make sure that we don't burn down the Airbnb, because that's very, very expensive. Especially when it's like a lake house that has like 8 bedroom, or like space for like, I don't know, 20 people to sleep in or something. But yeah, that was fun. Well, I can actually show the robot that I built. I'm not sure what I can talk about with it yet. But yeah, this is yeah, you can see that, right? Yeah, so this was supposed to be Fern from Freerun, but this is the first time I ever did like multicolor 3D printing, and she just looks like a goth girl. In that, instead of like Fern pouting from Freerun. But yeah, it's a plastic disc, and the screws fell out because I forgot to Loctite it. But yeah, made this in like probably like maybe 16-ish hours of active time CADing and printing and assembling, and I actually got like 8-ish hours of sleep and eating and stuff. So yeah, but I'll see if I can talk about that in better detail if I can. I think that'll be my Thursday stream, is to go over that. But yeah, so the Planathon footage, we did film it. I'm not sure what the plans are to release the fights from that. Hopefully you can release some. That'll be pretty fun if we do that. It wasn't as unhinged as the first Planathon, which happened in, I think, May. I don't think we're ever gonna get footage out of that. If you want to watch those video clips, I think you're just gonna have to track one of us down at a real-life event and ask if you can watch some footage from our phones, because it's whoa, my hair just went crazy. Because yeah, it's pretty unhinged. But yeah, the drive to Dallas really sucked. It was like it's normally like a 3-hour drive to Dallas, and the actual Airbnb was like another 45 minutes out, so we're expecting like a 4-ish hour drive. And since like it's the holiday-ish season, then like everything is Yeah, Chris's robot last time was, I'm not sure if we can post that on YouTube. I hope we can, because it's funny, but, I mean, you can find pictures of it if you look hard enough. Yeah, so for those that are unfamiliar with Plantathon, which I went over super briefly, that we just cram, like, about 12 to 16 builders in an Airbnb, and we have to do, like, a plastic robot in, like, a plastic ant weight in, what's it called? In, 24 hours. But we also have to, let's see, the rules changed between the two of them. But, like, so for the first one, you were required to, like, wait, I'm not sure if I should say that yet. Fuck it, I'll say it. Yeah, so it was kind of like a drinking game or something. You had to drink or do an equivalent to that. While you were designing the robot and printing it. It wasn't required while actually putting it together, because power tools and stuff, I don't think we wanted anyone drinking while using power tools, even though it happened anyway. And anyway, what was I talking about? So yeah, we had to do that, and we also had a parts draft where, like, everyone brought, I think, some drive motors, some wheels of their choice, some, or I guess other locomotion stuff, a roll of PLA, weapon motor, stuff like that, and we had to draft those parts, so, like, everyone just put all of those on a table, and we did, like, a serpentine draft where everyone got, like, a random number for their pick order, and we just went first to last, and last to first, and first to last, until everything was drafted that everyone needed. And on top of the parts, we also drafted quirks. And so a quirk was a weird requirement of either your robot or driving your robot. And so, let's see, some of those quirks, one of them, I think it's called Engineers Without Borders or something, and that one you had to make your weapon if it was, you had to make your weapon in the shape of, I'm not sure if it was just the weapon or if it was just any part of the robot, but I think some significant part of the robot had to be made in the shape of a geographical border, and so that's the one that I picked last time, and so I had a Texas-shaped blade for my horizontal spinner. It didn't do too well because I didn't try hard it. I just straight up made Texas without, like, trying to make the teeth actually protrude out. But what else? Yeah, there's the structural dick. We had to have a phallus-shaped, very important structural item, and for the robot that we're talking about, Chris's robot, yeah, the weapon was shaped like a penis. And the winning robot, that was made by Ryan Liu. That one, you had to, I think it was called Pee Pee Poo Poo, and I think the quirk was called Pee Pee Poo Poo, and, like, I'm trying to remember what the exact quirk was. It's something like, anytime your robot was not facing the starting direction, like, I guess, facing out the corner that it starts out of, you had to shout Pee Pee Poo Poo, Pee Pee Poo Poo, Pee Pee Poo Poo, or else you would start to be counted out as if you're immobilized, and Ryan ended up taking up first in that event, but the footage is very cursed, so I'm not sure if that's ever gonna get posted, but yeah, let me show my robot again. Yeah, so the quirk that I drafted this time was called cosplay, and so you had to like make your robot some recognizable character from something, and so yeah, that was supposed to be Fern from Freerun, and I wasn't exactly very creative about that. I just literally traced a picture of her and tried to 3D print that, and it slightly worked, but no one could recognize her, and they just ended up renaming the robot to Purple Panda because we decided that we weren't going to pick the names for robots. We're going to let everyone else decide the name of your robot. But yeah, it's a two-wheel drive Drisk. Nothing really crazy or special about it. But yeah, the drive really sucked. It was like 6 hours long instead of like 4 hours long. But at least the drive back was like only like 3.5 hours long as it should have been. Yeah, that robot, the hub robot, that one, so we had to, one of those quirks was, I think it was called copyright infringement, and we had to design a robot whose theming was a direct knockoff, or a direct copy of an existing real-life trademark or brand or something. And so with that robot, the builder picked Pornhub, and it was very, very fun. And I believe that it actually, I think it took second or third. I'm not sure. It was definitely in the top 3. It was undefeated the first 3 rounds at least. I think it made second. But yeah, let's see. So, yeah, what are we doing today this stream? Oh yeah, so we're going to be, learning, or I guess y'all are going to learn and watch as well, actually, I'm going to be learning too, because, we're going to, be modifying one of my robots to drive with a PS3 controller, and then with the PS4 controller, and then with the PS5 controller. And I'm going to be trying to write that code from scratch, just so it's kind of like, I guess, a learning process, and so that the stream isn't entirely like black magic and people can actually follow along instead of being like, where is this code coming from? And I'm also going to try to not vibe code any of it. I have Copilot installed, but yeah, I mean, I've been a professional software engineer for like 8 years, so I know how to do this without doing that, but it can be super duper convenient, not gonna lie. I mean, we're gonna use Copilot just a little bit just for like autocomplete, but in general, we're gonna be writing like 90-ish% of the code that's not from libraries ourselves. We're gonna be doing it for PS3, PS4, and PS5 controllers, which you actually need some different hardware for that, but I'll go talk about that in detail when we actually get into it. And we're gonna just modify one of my robots to do it. So yeah, in typical fashion, I have my workbench set up for show and tell. So yeah, let me go get that stuff. Doop 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 doop. You're seeing my virtual workbench, not my real one. I'm gonna switch the camera pretty soon. Which I can still read chat actually, because I have like I have an iPad here, so I can read chat from there. Alright, let's switch to avatar view. Alright, so yeah, show and tell. I think I'm actually gonna flip the camera upside down so that I don't have to keep flipping it over, because I keep forgetting that it's the other way around. Because I had to flip it over, I think, for my other stream. I forgot what I was doing, but I was doing a thing that I wanted to, like, have it flipped over. Okay, cool. So, yeah. Alright. So, this was, the first combat robot that I built, Data Collector. And this one, I actually drove, it's in, I think, its first 3 events, using a PlayStation 3 controller. Where's the PS3 controller? I can see the PS4 and PS5 controller. Oh, here it is. So yeah, I drove this one with a PS3 controller. We're not going to be using the exact same code that I used in Data Collector, because Data Collector had a bunch of sensors going on in there, and like RGB LEDs and stuff. And that's kind of out of the scope of this video. But yeah, it was driven with a PlayStation 3 controller. And so there's only kind of a slight modification on here. I took it apart, which I'm not going to get into, I don't think, this video, because I don't want to really touch these ones. And this one's already modified. But, so the modification on this one is pretty easy to explain. I just took out the original lithium battery in there, because, like, at this point, like, what, PlayStation 3 came out, what, something like 18 or 19 years ago or something? So the batteries in those controllers are probably not that good anymore. They probably won't last very long. And so I replaced that with, like, I think a AAA battery pack. We can actually open it up and confirm that. It's not like glued in. I think it's glued in. So it might require some force. I don't know if there's like a screw in here or something. Is it? Okay, no, you can just slide it off. So yeah. Don't know if I need to grab some new batteries or if these are actually good still. And I have a multimeter, so I can check that. If not, I have a bunch of batteries anyway. But yeah, so it has an external battery pack with a switch. And so I was talking about how we're going to be fail-safing stuff, and so if you're not familiar with Robot Combat fail-safes, one of the things that you have to do is, like, they're going to ask you in the test box or the arena before the event when you're trying to pass safety that you need to, like, keep the weapon on. So let's pretend that the weapon's, like, spinning, like, woo, it's spinning! You're going to be holding it down, and then you want to turn the controller off. And then it should stop spinning like 10-ish or less seconds later. They're going to ask you to do the same thing with drive, so you'll just be keeping it spun, you'll turn off the controller while the robot's spinning, and then it should go to a stop within 10 seconds. And so kind of the problem with doing this with like with gamepads is that they don't really have like, I guess, hard power switches like that just disconnect the battery. They just you have to like hold down something for like 5 or 10 seconds or so, and I know that sometimes some event organizers allow that, but I can imagine that there's some that are not cool with that. So just to be super duper safe, I wanted to have a hard power switch that just completely disconnected the battery from that. And so yeah, I just opened this up, just popped out the original battery and just soldered in this 3 AAA battery pack in there. So yeah, that's a thing. And so later on though, I replaced the PlayStation 3 controls with the Steam Deck, which we're definitely not going to be covering in this video because, oh gosh, that could probably take like 3 or 4 streams to explain how that works. But yeah, Data Collector used PlayStation 3 controllers for the first 3 events, and then I wanted my subsequent robots to use Steam Deck. So the last event that I drove Data Collector was with the Steam Deck, and then let's see, my second Beetle 2FA, that was always on the Steam Deck, and Injection, which oh, here's a more complete one. Injection, she used the Steam Deck also. But, so this little guy, though, Captcha, which this actually isn't functional because I sold the real one, this is just a mock-up, is a mini-bot that was driven with the PlayStation 3 controller, though. So, I had to just kind of whip that up pretty quickly. But, yeah. So yeah, I guess that in this video we're gonna be, just wiring up, I guess probably Injection to use PS3 controller. Not going to do the full controls, not going to do any sensors like that or anything fancy, just kind of the minimum that we need to get a combat robot viable and passing safety and controllable using that. And so let me go see if I can find, like, in my normal controllers, not sure if I can find one right now, but I'm gonna try. It's not up there. Could be in this box. I also could just not have it anymore. I don't think it's gonna be in here. This box feels way too light. Are you in here? You're not in here. Okay, I don't want to waste time looking for it, but like, yeah, I do have a couple normal RC controllers around here. Although I guess I do have to point out, though, that, like, some controllers, though, they also can't be turned off with the, with a discrete on-off switch either, so, I don't know, maybe we don't have to modify the controller. I don't know, I just ask your event organizer what's necessary for that. But, yeah, actually, let me go run and grab some AAA wait, no, I should probably check if they're even dead in the first place. Okay, so let's get this multimeter out. And I guess I'll start charging these controllers anyway, because I don't know if they're even full or not. and it's gonna be a while till we get to them, so might as well just start charging them right now. I actually modified my PS4 controller to take what's it called, USB-C. Okay, so those are charging, and we'll see if this one needs batteries replaced or if it is already good. Okay, that's DC. Okay. I'm just gonna go check each one individually. That's not a good sign. That looks dead as hell. Oh, that one's actually pretty full. Well, not pretty full, but it's usable, I guess. I'm actually gonna just take it out. Yeah, I think that we're gonna have to change these batteries out. If so, I'll go grab some. Yeah, that's dead. Do I have my charger plugged in already, actually? That's very dead. And, that one has a bit of juice. Okay, I thought I had a battery charger around here. Let me go grab my, batteries real quick. Pause. Does that work? Yeah. Okay, cool. I got my batteries. Okay. So, when I plug these in and turn on the switch, unless the switch is already on, then we should see it blink. I think it's off because I'm pretty sure that I scribbled that dot of silver Sharpie to indicate that it's on, or to indicate that's the on position. Okay, yeah, you can see that blink, so it works. Alright, so what was I doing? I was doing something. I am gonna get the weapon safety locks, actually, for injection if we're gonna be working on her weapons and stuff. Alexa, set lights to white. Weapon safety locks. And that is her obnoxious power on thingy. The screw switch screwdriver, that is a gigantic syringe. It's actually really annoying to like dig for this stuff when I have this gigantic face tracking phone mount thing just sticking in front of my face. Okay, here's weapon lock number 1. And where is number 2? I wonder if you can hear those sound effects though. That is not the correct thingy. Need the correct thingy. I mean, would it still work anyway? Let me check. Because, I mean, I only really care about locking the, what's it called? I only really care about locking the blade, not so much the arm. So, if the blade is locked, then we're cool. Did that switch? That did not switch. There. Okay, we have the weapon blade lock at least, so that's good enough. But I know that one of these, the weapon doesn't like spin up anymore because something like when the phase wires melted or something. Yeah, it's pretty crazy trying to stream stuff regularly during this like holiday season just because there's like so many things to do that like get in the way of the normal schedule. I'm not sure if it was a good idea to, like, start doing this right before holiday season starts, because now the algorithm's all confused, and the more I learn about how the algorithm works, the more I'm like, this is a pain in the ass. Okay, but anyway. Yeah, so, I guess I'm gonna just start off, I'm gonna start off doing this anyway. Oh yeah, I want to test out which weapon motor is actually, good. And then we'll just work with that. Well, actually, do we even want to do that? Just because, like, I'm not even gonna be, like, fighting this or be able to show you stuff in the box. So I guess we don't have to worry about the weapon motor. Okay, I guess we're just gonna leave it disconnected to just, like, worry about the arm as if we're gonna pretend that instead of a hammer saw, we just have a normal hammer, and we're just gonna not plug in the saw part. And that'll be, safer to demonstrate on the workbench. So yeah, it doesn't matter then which one we use. I guess I'll use the other chassis since it's more complete with the front end. Okay, so got my drill and my stuff. Where did my dishes of bolts go? Whatever, don't need it. Okay, so unlike the very first stream that I did, we're not gonna do a full disassembly. We're just gonna take off the top plates so that we can, like, access the electronics. Yeah. Although, now I think about it, this actually might be kind of a confusing stream to do with this robot, because it has, like, a 4-in-1, so maybe I'll just not use the 4-in-1 and stuff. Yeah. Probably should have thought the stream through a bit more before doing this. But anyway, yeah, I guess that means that we're just gonna be converting this to a completely normal robot and just forgetting all the electronics that I've already had in here. Actually, that does make things kind of easier. So I'll just be putting in... Why is there a scrunchie in here? So yeah, I guess that just means that I'll just be putting in, like, normal ESCs and stuff in here then. Hope I can find them. I actually think I have to take off that arm also, just because the wiring goes through there. But that'll just make it easier to work with. But yeah, I like how I said that we're going to, like, do a PlayStation controller robot control, and, like, I haven't actually even started doing that yet, just disassembling the robot right now. But it is actually just kind of easier to start off with just the drive at least. Or, you know, we could actually just kind of bullshit turn this into a lifter bot or something. Yeah, let's do that. That sounds fun. Okay, so change of plans. We're actually gonna turn her into a lifter, cause that'll be fun. And I can actually show that on stream. If I can find my servos, though. Okay. Alright, so let's just get rid of all the electronics, and let's just pretend that we're not gonna use any of that stuff because it's too advanced for the stream. Okay, so we have just a normal base here. Mostly normal-ish. We have left drive motor and a right drive motor, and it's 4-wheel drive. Pretend that this tire does not exist. It does exist, actually. I'm gonna gaslight you into saying it exists. And so, we need to use... Okay, there's a speed controller. I guess I do have speed controllers here ready. Yeah, so I'm gonna go get a couple speed controllers, which are probably just lying around here. I hope they're just lying around here, because that'd make things easier. And I also hope that they work. Okay, so that's BL Heli 30... 2 also, and I think I last only use it for drive, and if so, that makes things easier. And I also was a weirdo, and what did I do that was weird? I completely changed the soldering pattern, or the wiring pattern, I guess, on those, like, consolidate the wires into, like, weird stuff. Basically, so most ESCs, you're gonna have, like, the normal power connector, which is gonna be, like, for this weight class, usually XT30, and then you're gonna have, like, usually a DuPont, signal pin, or signal wire, sometimes with the, what's it called? I think the battery eliminator circuit is what BEC stands for. But in this case, I actually just combined all of that into a single connector to make it easier to wire up, but at the same time, that means it's non-standard, which means that it's not great for a video guide, so I will have to undo that. But that's okay. I just hope that these actually still work, because I haven't used them in a while. So I'm just taking off the tape. And so, let's see, what is the order of operations that I want to do here? So, I need to find an ESP32 somewhere, and then we're going to wire that up. I think that we should probably just wire up a servo to it, just since that's like the super duper easiest test case for this. And then we're going to hook up the drive motors to it. So yeah, these are the electronic speed controllers. They convert the raw battery power and the signals from normally receiver, but in this case from the ESP32, into, I guess, motor motion. In this case, these are for brushless motors because there's like 3 wires coming out of them, and there's 3 wires coming out of the brushless motors, and the brushed ESCs usually look different. Although, on a technicality, some ESCs, like the ones that have AM32 firmware, and the ones that have, and the VESC ones, they can actually use both by just ignoring, or they can actually do both brushed and brushless just by ignoring one of the phases out. But that's more advanced stuff. We don't need to talk about that right now. So yeah, I guess I'm gonna go find an ESP32, which I have like a bin of just random microcontrollers, if I can reach it, because there's a ton of crap in the way, because my place is messy as hell. And I'm just gonna start off, I'm gonna see if I can find just like the most normal ESP32, but it doesn't really matter which size you use for it, as long as you, like, especially if you're just doing like, I guess it kind of does for combat robot stuff, since we're trying to min-max stuff for size, but like, if you're doing just kind of general robotics, then you can use like the full-size one. If you're just prototyping, the full-size one's fine. There's lots of ESP32s out there. Is this an ESP32? Yes, that is. That's an ESP32. And that is very similar to the standard size. I think the standard size is just a little bit bigger, but I don't actually know if it might be, what are you? You're an ESP32 S3. Yeah, I'm pretty sure I have like 4 or 5 different sizes of ESP32. And so what is an ESP32 anyway? So if you've heard of Arduino, or like if you've heard of like Raspberry Pi Pico, oh yeah, this is also an ESP32, by the way. I'll just take that out as an example. So if you've heard of like Arduino or like Raspberry Pi or whatever, and Raspberry Pi mentioning that actually makes things kind of confusing also. Oh, speaking of level, there's a Raspberry Pi here. So let's just get the Raspberry Pi stuff out of the way, which is kind of the more confusing bit. So, well, actually, nothing's easy. But anyway, so Raspberry Pis, just like this one, this is basically an entire computer on a single board. That's why it's the class is called single board computer. So it's going to run like Linux or whatever you put on there, and we don't really want to use these too much just for like something as simple as like just a basic combat robot. I mean, if you're doing like self-driving AI stuff and you're doing like machine learning and whatever, and if you want to put that inside the robot for some reason instead of like outside the robot, then I guess you can, but really it's kind of overkill. Now, I did mention that using talking about Raspberry Pis is a little confusing, and that's because oh crap, that's a board that my friend made that does this. Okay, I need to talk about that thing later. But anyway, so yeah, I mentioned that gets a little confusing with Raspberry Pis because they reuse the same brand for their Raspberry Pi Pico, which I might have one of those. Yeah, this is actually a form of a Raspberry Pi Pico. Let me see if I have like the normal Raspberry Pi Pico though. The one that's like recognizable as the Pi Pico when you see it. That's a Teensy. Do I have any Pi Picos left that I haven't opened or used in a project? I'm not sure if I actually do. I guess any like default ones instead of like weird form factor ones. I guess I could look up a picture of it, but that's not as fun. I think this is one, actually. No, that's not it. Welcome to my stream. It's gonna be like 80% just digging through stuff. While I have this, like, annoying face tracker thing in the way. Okay, I don't want to waste more time looking for a Pi Pico. But, so... yeah, what's the company called? Is it the Raspberry Pi Foundation or something? Well, anyway, so, I'm actually just gonna look at the picture of it anyway. So, the Raspberry Pi Foundation, I think. Let me make sure that's correct. Yeah, Raspberry Pi Foundation. So, let me switch over the view thingy, if it will let me. Gosh, no, not that one. Oh my gosh, it wants you to keep logging in. I hate this, like, meta of, like, oh, we logged you out, and now to log you back in, you have to log in with, like, 50 different things. It's really annoying. Like, it's better than getting your account stolen, but, like, it's still annoying. But anyway, okay. I'm gonna switch the view over to show my screen. Is that correct? Okay. So, yeah. Actually, I haven't really gotten in a good, what's it called? I still haven't really figured out how to not dox myself, so every time I, like, hide the window, that's because I'm, like, hiding stuff, because I don't want to dox myself. But anyway, so yeah, the Raspberry Pi Pico versus the Raspberry Pi, 4 Model B. Oh no, the 5 is out now. So yeah, this is the one that I was talking about that I was showing here, actually. Where did I put it? Okay, never mind, I'm getting distracted. So this is like just an entire computer running Linux, and you can run a bunch of programs on it at once. That sounds cool and powerful, right? But the problem is that it's a lot larger, it's a lot bigger, it consumes a lot of power, it takes like at least 20 seconds. You're gonna be, if it restarts in the middle of a battle, then you're gonna get counted out, period. That's just gonna happen, because it's way more than you actually need to drive a robot. And in this case, less is more. You don't want too much, because that just means more stuff is gonna break down. More stuff is or there's more parts that can break down. There's more things to get in the way. It takes longer to reboot. And so I mentioned it's kind of it's a little confusing, because like there's a Raspberry Pi company, which is Raspberry Pi Foundation, And then there's like the Raspberry Pi most people are familiar with, which is the whole computer, and then you have the Raspberry Pi Pico, which is this little microcontroller unit. And technically, I think that chip is actually the microcontroller unit, and the whole board is just called a dev board. But yeah, and so this is actually kind of closer to what you want to use to control a more basic robot, because it only runs one program at a time, and it takes like less than a second to reboot if it like loses power or something in the middle of battle. It's a lot smaller, a lot lighter, and it's not going to have as much lag. You don't have the thing of like, oh no, this random utility decided to boot up in the middle of the thing and now it's all lagging and stuff. You don't have to log into it. You don't have to worry about any of that stuff. And so, yeah, you have like the Pi Pico, and then I mentioned Arduino. And so Arduino is probably the thing that most people have heard of also. And so this is closer, well, no, this actually gets a little bit confusing too, because Arduino, just like Raspberry Pi, is not a specific board. It's a company or a brand or something. I don't know. They got bought by Qualcomm, by the way, recently, and that kind of sucks because they're... Anyway, that's a whole different tangent. But yeah, so Arduino. It's a family of microcontrollers, also mostly microcontrollers. I think that they actually have an SBC. Let me look up if that actually exists. Do they have an SBC yet? Yeah. I guess that there is an Arduino SBC now. I don't know if this is official. It doesn't look like it's official, but it wouldn't surprise me if they have an actual SBC now. But there's like tons of different Arduinos. A lot of them, the ones that you've probably heard of, like the Uno and the Nano, are actually really, really ancient and super slow and stuff. But they do have some modern models out too. But yeah, it does get kind of confusing. It's like when people say, oh, I drive a Ford, and it's like, what do you mean a Ford? Do you mean like a Ford F-150 pickup truck, or is it gonna be like a little Ford Focus, or like maybe a smaller Ford Maverick pickup truck, or is it a Ford Bronco? Like, it's just kind of confusing because people, they'll be like, yeah, I have an Arduino in it. It's like you don't know how powerful this Arduino is, or like what its form factor is, or its capabilities, because you just said the brand name, you didn't say the exact model. But yeah, and so why am I even ranting about this? Oh yeah, so ESP32 though. So ESP32 is made by a company called Expressive, and it's a line of controllers, microcontrollers. And so this isn't as confusing though, because they generally have the same kind of capability. Like, I don't know exactly what ESP is exactly, because there's like the ESP8266 and the ESP32, and those are kind of similar, except the 8266 only has Wi-Fi, and the 32 has Bluetooth and Wi-Fi, and then you have some newer versions of the ESP32, like the S3 and the C3 and stuff like that. But the important part, though, about the ESP32 compared to like your typical Arduino Nano or Arduino Uno or something, because there are wireless Arduinos, but they're not very well known or well used, is that like all of the ESP32s have Bluetooth and Wi-Fi on them. And this is what we're going to be using, actually, so that we don't have to have like a separate Bluetooth board. We'll just be connecting directly from the PlayStation controller to the ESP32. And so you've probably seen lots of like robotics projects that use like, I'm just gonna look at like Arduino Servo, because like, I guess if we just look at this, like it's just a board with a bunch of pins on it and a USB port. If you look at the Arduino, it's basically the same thing. You have a bunch of like most of the ones you're seeing on here are Uno form factor. Have a bunch of pins. You have a USB connection. If you go back to the Raspberry Pi Pico, we also have a bunch of pins here. We have the USB connection. And so what's important about the ESP32 is that it has the Bluetooth radio built into it. And so I don't think that any of the basic Pi Picos have a Bluetooth radio inside of them. And I think only some of the later models that are just not as like common or as supportive of Arduino use Bluetooth. Although it does get a little bit confusing here too, because because there's actually different standards for Bluetooth also. You have Bluetooth Classic, which is kind of, whoa, that got weird. You have Bluetooth Classic, which, as the name implies, is kind of an older form of Bluetooth. And I don't know the exact differences here. I just want to say that I think that Bluetooth Classic operates kind of more serially, like it's kind of closer to like how USB works, where it's just like a lot of data just kind of going back and forth and like just kind of one pipe in, one pipe out. Not 100% sure on that, so don't quote me on that. While I think that with Bluetooth LE, it's not so much like having kind of two continuous pipes of information going back and forth. It's more so you just kind of like set up like, oh yeah, this thing is this value now, this thing is this value now, this thing is this value now, and then the other thing is like, okay, what value is this? Let me check. What value is this? Let me check. I'm not 100% sure about that. I think that's kind of how it works, but that's not like my forte really, so I'm probably oversimplifying it, but they are different protocols and they're not directly compatible. Like if you have a Bluetooth LE, which LE stands for low energy. If you have a Bluetooth LE radio, you're not guaranteed that you'll be able to connect to something with Bluetooth Classic. Usually you're not going to be able to unless you explicitly have a Bluetooth Classic radio in there. And it's the same thing for the other way. And so why am I talking about this? It's because we actually changed the protocols that we talked to with the PlayStation controllers. Let me actually go grab the whiteboard. And where did I put the other controller? Okay, I'm just gonna move these controllers here. And I'm gonna go get the whiteboard. And I don't know what this stuff is on here, so I need to erase it. But now the whiteboard is getting caught on stuff. And I need to get some, do I have my isopropyl alcohol? Where the heck is, where's the paper towel? I'm gonna go get a roll of paper towels real quick, and I'm not even gonna bother to change into the pause scene, so you'll just see my mocap going crazy. Okay, I'm back. Yeah. Did it, is this thing changing? Let me just make sure it's changing. Okay, yeah, it's changing. Cool. Okay, so, let me go wipe down this whiteboard real quick. Oh gosh. That is correct, this whiteboard is a pain in the ass to erase. So yeah, I'm explaining why there's a different Bluetooth protocols because the PlayStation 3 and PlayStation 4 controllers only support Bluetooth Classic, while the PlayStation 5 controller, I think, only supports Bluetooth Low Energy. And it's kind of the same, and so we need to pick the appropriate microcontroller, the appropriate ESP32, which supports either Bluetooth Classic or Bluetooth Low Energy. And wow, this whiteboard is not erasing well. It is taking a bit of a while to erase, and I can't find my isopropyl alcohol, and I don't know if acetone is a good idea on whiteboards, so I'm not going to try that. Okay. Alright. So yeah, let me go get the controllers out. Okay, PS3 controller. That's weird. PS4 controller light was like red for a second. I don't know what that means. And PS5 controller. Okay, so where'd the marker go? Alright. So this is almost dead. Can you even see that? Yeah, you can barely see that. PS, oh my gosh, it's totally dead. Do I have any markers here? If not, I'm just gonna go, okay, I'm actually gonna go get like some paper and some Sharpie. Doop, 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 doop. Okay, I think I found the paper and Sharpie. Okay. Now, well, I found the paper, I just need to find the Sharpie now. A visible Sharpie, that is. Okay, cool. I wonder if it makes sense to, like, have a separate one per. Okay. So we have, there we go, we can see this. PS3, PS4, and PS5. And so this only uses Bluetooth Classic. This one also only uses Bluetooth Classic. But the PS5 controller only uses Bluetooth Low Energy. And so that means that we can use... Is this the classic one? Yeah, that's a classic ESP32. Okay, where's my scissors so I can open this? Scissors, where'd you go? Actually, I'll just use a knife. Knives are more fun anyway. Where's my knife? There. Okay. So, this is a ESP32. Just a normal one. The classic one, or I guess like the OG one, doesn't really have like a name, I guess. And so this is an ESP32C3. And so I do want to show, because it definitely looks like that this one is bigger than this one, which it is obviously. But I was rambling on earlier about like trying to find like the normal size ones. Because if you look here, a lot of these are different shapes, but they are all the same thing, just kind of rearranged for whatever use case. Like sometimes you don't need that many ports, sometimes you want a bunch of ports. Oh, and here's a case of something very confusing. Not all Arduino Nanos are the same. In this case, they have an Arduino Nano that uses an ESP32 as its microcontroller. And it's way faster than the original Arduino Nano, and at the same time, a bunch of projects meant for the original Arduino Nano are not going to be compatible with it. So yeah, yeah, that's just another case of like calling things just Arduino or just calling things a Raspberry Pi. It's not really helpful. It's really confusing. You have to specify the exact model of it. But I guess kind of going back to this. So this is like kind of the standard. Is that it? No, that's an S3. Okay. Hold on. It has like a... Oh, yeah. It does actually have... So, I don't know how it's pronounced, if it's W room or if it's room or something, but, yeah, so this is what kind of the standard ESP32 dev kit looks and is shaped like. And if we go back to the workbench, we'll see that this one's almost exactly the same. It's not quite the same, but it's very similar. You can see that, right? Yeah, you can see that. But yeah. There are versions that condense it down, like, I wouldn't say this is actually smaller. If anything, it's just kind of more square-shaped, but it's definitely wider, but it's not as long. But, yeah, you have this form factor. There's the one that Adafruit has, which is this one, which I showed I have one of those. And I might actually just use one of those just because it has USB-C on it and because it's a lot smaller and will actually fit inside the robot. Yeah, let me just go take that one out of the packaging, wherever it is. There we go. Big burp. So yeah, these two are actually the same thing. Like, it doesn't look like it, but they're the same chip inside of it. Smaller packaging. This one obviously has a lot less pins. So if you need all those pins, you shouldn't use this. You should use this one or some other form factor. But yeah. And so yeah, so that's kind of the classic ESP32. Wait. Oh no, this is the S3. They have a version of that though, which is just the normal one. Yeah, this is really confusing. Oh, and they even have... Oh no, that's not a Pi Pico. Okay, I'm just confusing myself, and I'm probably confusing all of y'all, but the whole point is that these boards can have the same chip and, like, come in completely different size and shapes. And I guess that the other point is that you can have the same size and shape, and it'll have different chips on it. Like, this one has the later gen ESP32S2. I think we just saw one that has a S3 on it. Yeah, this one has the S3 on it. There's probably one that has the C3. But yeah, and so for some reason, I don't know why they don't have one that has both Bluetooth Classic and Bluetooth LE, but like, I guess kind of the easier way to think about it is that the older gen of ESP32 is going to have the classic Bluetooth, while the newer gen of ESP32 is only going to have the Bluetooth LE. If anyone knows if there's like a model that has both, feel free to correct me, because I'd love to know if there's definitely one that has both, because that's really convenient. But yeah, so we're going to be using, let me see if I just type in that into it. And let me just confirm that this is actually the correct ESP32, or if I just played myself. I can't even read that because it's like so tiny. Is that upside down? ESP32 Pico V3, which I'm guessing is version 3 instead of like S3 or C3 or whatever. Pico. Okay, yeah, so I'm not going crazy. So this is the one that is basically the same as that original ESP32. Or it's actually just see what I show here. Yeah, so these are basically the same thing, just different packages. While this one is a completely different generation of it. This is one of Injection's control boards. Let me disconnect that so it doesn't get torn off. Is it glued in? No, it's not. Okay. So yeah. And this one next to it, I believe, is the same thing. Let me just check, because it's hard to read that. If they're not the same, then they're like sister ones from the same generation, but this one is this one an S3? No, this one's a C3, and this one I think is an S3. So they're from the same generation, I think, and they're pretty much very similar. I want to say that the S3 is dual core and the C3 is single core. I'm not 100% sure on that. It's been a while since I touched them. But yeah, and so I guess, yeah, so the first thing that we're going to start off with is we're just gonna forget all the new advanced ones. And there's a massive mess on my desk right now. And yeah, damn, I really used 3 sheets of paper for this. Yeah, we're just gonna clear this off now, and we're gonna get started on actually using this to control a robot. And we're going to start off with the PS3 controller because I've actually done that one before. I actually have not done the PS4 controller or the PS5 controller versions, although I do understand it's, I think, just as easy to do them. But I did want to cover all those and learn some new stuff on my own in this video too. So yeah, let's see. So where do I want to start? I think the first thing that we should start off with is we should probably power up that ESP32. And so we don't want to do this off of USB, although you can do that for many projects. You're going to want to power this off of a proper LiPo battery. And so what does that need? We need the batteries, which there's a ton on this side of the workbench. Just trying to figure out if I want to keep things simple or if I want to make things a little more difficult on myself. Let's see. We're gonna keep it, I guess, fairly simple. Let me see, what's the power rating on this? This can take 2 to 5S. I guess, actually, if I keep it simple, and if I just use 2S on this... Nah, I'll just use 3S. Yeah, let's use 3S. But then that means that, I'll need, like, two buck converters, yeah. That's okay, they're easy enough to solder up. Electronics. Where is my box of those? Is this the one with the boost and buck converters? It is, and I am low on those. I need to order more of those. Okay. So yeah, gonna need at least 2 of these, and these aren't like the most reliable. So I'm gonna take out like 3 in case something kind of sussy with that. And then, what else? Need some wires. And I don't think I'm gonna bother with like a proper power switch because I don't want to unsolder stuff right now. I say that, I'm gonna be like, fuck it, I want to do it the proper way, I'm gonna do that. But I need to find some power switches first. Or I might just reuse, yeah, I'll just reuse the one from here since like injection's getting completely rebuilt anyway. So yeah, there's the roll of black here. And then need to find my XT30s. Where are my XT30s? It could be up here. Yeah, for Planathon, I just literally took the boxes that I had from injection and just kind of, oh, I already have a spare power switch here, so I don't even need to like undo one. Yeah, cool. Oh, and I have a bunch of converters there anyway. Okay, so I'm gonna go find a battery connector. Yeah, cool, that'll work. I'll just get that battery started charging if it's not already charging. Where's my charger? Where's my charger? I just realized I have a spicy battery somewhere and I don't know where it is, and I need to probably find it and throw it away before something bad happens. That's a topic for another day. Okay, so let's just charge up this 3S battery. I don't know why I picked 3S. Oh, is it already charged? That's probably not good. Oh, shit, this is not the right battery chemistry. So this weekend we were working with, we weren't using LiPos, we were actually using just some normal lithium-ion batteries. I forgot, can this do... Is this HV, or do I have to just get this to normal? Yeah, this is HV. Cool. Okay, yeah, let's just get that started. So, let's see. The way that we're gonna do this is probably easier if I draw it out. Not sure if I should use red Sharpie for literally everything, or if I should, I mean, if I just use purple Sharpie for everything, then, I guess that's nice, if I can find it. I don't want to spend time looking for Sharpies I don't want to spend this whole stream looking for parts. That's just really annoying. You know, I have a purple gel pen. Let's go. Well, it's not gonna be thick enough for you. Fuck it, we're gonna use brown. No, is that black? We're just gonna use brown. Brown's neutral enough. Like, I know it's usually ground, I think, but whatever. Okay, so let me make sure that y'all can see that. Okay, so we have battery and shit, I forgot which side is positive. I think the fat side is positive. Okay, battery symbol. Yeah, fat side is positive. Okay, so we have that. And then this is gonna be the switch. And then we want this to go. Okay, so we want just the raw power out to go to the two, what's it called? The two ESCs. I'm gonna say that this is like drive. And I'm not gonna do the signal lines, it's just power. Yeah. So that goes there, and then that goes there. So then this is just getting the raw 3S. And then ESP32, I think, only wants to take up to 5 volts. Something like that. And yeah, these have 5 volt settings, and you have to adjust it for whatever the hell the servo wants to take. It's also possible that we could just use like a normal servo that just uses like 5 volts. But yeah, so let's branch this out. And so this will go to buck converter, which I don't know what the symbol for that is, so this will just, yeah, this will just step it down to, well, I mean, technically I think that the ground's gonna be the same on that anyway. But, yeah, that'll make it so that that's gonna be like, what, 7 volts or something like that, and then this will still be ground. Is that ground? Yeah. And then we're gonna want a second one that, oh, I don't know why I did that. We're gonna want a second one that goes to the ESP32, but also converts that to like 5 volts. And so this one goes to the ESP32, and this one goes to servo, and this one goes to the drive stuff. Yeah, that sounds about right. Okay, cool. So let's get that soldered. I need to set up my soldering stuff, which pretty easy because it already exists, I guess. That's backwards. Okay. Oh, that's the wrong one. I want to use that tip. Tip is not that hot. Yeah, I want to use that tip. Okay. I'm going to squirt some water on that. Also, alright. Let's see. So I'm gonna go get my OmniFixo set up here. And this battery is actually really close to charging. It was not stored at 3.8 volts per cell or whatever it is, so it may not be in the best condition anymore, but oh well, it'll be useful for the stream. And I don't really build robots with 3S anyway. So yeah. And we're not doing anything like super high power, so I'm not even gonna bother with like the super fat wires either. Okay, and I want to find a servo also. Motors and motion, that's probably the bin that will have my servos in them. There's way too much stuff there for me to dig through all of it. I found my, oh, what's that? What is that? Where'd I get that from? Huh. Okay, I have no idea where I got this from, but, like, it looks like it's a brushless motor that has an ESC built into it, maybe? Because it has, like, a signal wire and the power wires going in. I have to look up what that is. I've never seen that before. That's cool. But anyway, just looking for my servos through my infinite boxes of messes, and I found more ESCs in case the ones that I found are not viable for this. Okay, that's just random brushless motors, speed controllers, more speed controllers, servo horns that will probably be useful, more speed controllers, a baby servo, although I want to use a much bigger one if we can, another baby servo. I'm realizing how many unused parts I have just kind of sitting around. But I want a big fat servo. If that's not there. Let's see. Oh, here's one. Perfect. Cool. Yeah, let's see that one. Although, I want to see what else is in this box, because I think I actually have one that's already, like, pre-wired with a converter that steps down stuff. And if it does, I'd rather just use that, because the point of this isn't let's learn how to wire up these converters. The point is let's learn how to do stuff with PlayStation controllers. Yeah, that's where most of my servos went. Okay, yeah. Oh, and there's a bunch of servo horns. Okay, cool. So I don't think I have any that have that pre-wired on, but that is okay. Let's see, this will take 5 to 8.4 volts. Yeah, I want to use all the power that I can from that, so let's wire up 2 of those then. Okay. So, what was I doing? Got my diagram here. And where is the XT30 that I just had? Oh, it's already in here. Okay, cool. Okay, this is heated up. Let's scrub that around and stuff. Let me turn on my, let me get this out of the way. Let me turn on my hot air station so that I can do heat shrink stuff. And yeah, I guess we're just gonna be soldering the stuff then. Is this plugged in? This is not plugged in. Something's burning. I'll figure that out later. Okay, let me just check on the camera that you can't see that. Have to go in a bit closer. Okay. So, where are my wire cutters? Found my wire strippers. Where are my flush cutters? I just had them. Yeah, I just unpacked all this stuff from the robot stuff this weekend, so like my tools are kind of all over the place again. thought I just had those flush cutters somewhere. Thought I had like 5 pairs of flush cutters too. I mean, I have a bunch just up here. Just want to use those particular ones since I've been using them for a while, and I've been pretty good about not losing my flush cutters. But I'll just grab these ones anyway. Ew, these ones are nice. I forgot I had those ones. Okay. Let's see. Want to put that on the switch. Well, first let's just get it on the XC30. It is really hot. I might need to turn up the AC. Why? So for some reason the weather has been like well, I mean, we all know why, but it's been well, there's lots of factors, but anyway, yeah, I think it was like 85 degrees today in Austin, Texas, and it's like, what, almost the end of November? And yeah, it's pretty warm. Not a fan of that. Okay. I really need to get a magnifying glass before my next stream, because like I don't have problems doing the soldering stuff normally, but when I'm doing it while streaming with like this thing in my face, which you can't see it with this whole like face tracking rig, it's a pain in the ass. Because I can't look up stuff really close. So I think I need to get like a magnifying glass for the next time I stream anything like this. Like when there's like combined light magnifying glass, maybe if it had like a fume like a soldering fume extractor, that'd be awesome. Okay. I don't know actually why specific sides are labeled for load or battery, if it matters, or if Seth just put that on so that people don't have to think about it. You're like, oh, I know which side it goes on because it says so. But yeah, I use the PCB, the JCR PCB switches at first. Oh shit, I forgot to put heat shrink on there. And I do not mess around with heat shrink when it's batteries, because shorting lipos is not fun. I mean, it is fun, but it's not fun to deal with the aftermath of it. God, there's like so much shit here. I'm just gonna go lock this camera view to the workbench also. Let me figure that out. Okay, that should be locked to the workbench now. So, if I start yapping about stuff and it's on the computer screen and y'all can't see it, please let me know, and I'll change it back to automatic. But yeah, I'm just getting some heat shrink. I should have cleaned up the space so that I wouldn't have to keep going back and forth, but whatever. Okay. Slipping that on. And then heating that with a little hot air. I don't actually know what temperature I'm supposed to do the hot air stuff at when shrinking heat shrink. Should probably figure that out. Okay, I'm just gonna stick it in that hole instead because that's easier. Okay, cool. And I remember that it was in like the instructions that I'm supposed to like put a nice ring of solder around that ring nut or whatever it is. Nice thing is that it gets accepted to it pretty easily. Can't see around the back of that. Oh, it looks like it worked. Cool. Okay, and then let's just get this side. Alright, cool. And since this thing isn't actually gonna fight, I'm gonna say that and I'm just gonna bring it anyway to an event. Yeah, I'm like, I don't need to take this seriously, and it's like, you know, what if I did bring it to an event? Okay. You know, I just realized I didn't even think about the length of that. Shit, I have to redo it! Like, it would have been easier if I just, pulled it off instead of... Whatever, I'll deal with it. Okay, cool. Calipers are in the way. Okay, so just desoldered that, and what was I supposed to do instead? I was supposed to get this robot. Then I'm gonna go put this here, and I'm just gonna approximate the length of it. Because, let's see. So the battery's gonna be in here, so we're just gonna have this snake through to here, and I'm just gonna give it some extra length because this isn't even like super thick wire. Cool. So then that goes there, and then this will go into that cavity, which is where we're just gonna keep all the electronics at. And then where's my black wire? And then this does not need to go to the switch stuff, so just put it there. Okay, cool. Ow, that's still hot. Alright, now we actually have the real length of stuff that we want. Alright, so just stripping that wire. Stripping this wire, and we're going to solder it onto the X230 and hold it on using the glorious OmniFix. So wait, what if I do it like this way? So that's not in my eyes. Something made a weird sound, and I'm not hoping that's not from the battery somehow. Yeah, you know, that actually might be more serviceable. Okay, cool. And I'm gonna just tin the ends of these also. Just so that we don't put like so much heat onto the connector itself and just kind of deform it. Okay. Yeah, I think that's working. Let me look at the screen. Yeah, that's actually a lot better. We'll do it sideways now instead of in front. Okay. Cool. Then we'll just solder that. Is that a good enough joint? It's a little bit bulbous, but it'll work. And then this one. Fuck. Oh yeah, that's seated in there nicely. Alright, cool. And then let's heat shrink that. Let's see. Okay. Let's shrink that. Let's actually hook up the switch this time. There's a switch. Oh, and there are my tweezers. Okay. Oh, what's the best way to do this? Whoa, what just happened there? That was weird. Okay, cool. Pull that out. Then... Can I tin that yet? Let me tin that. That might make it easier. Okay. And I don't think I actually have to hold it with that. Just melt that. And then let's see if we just like force that in. Yeah, just like that. Okay. Cool. And then the other side. Yeah, I'll just have it lodged like that, awkwardly. That works. Okay. Cool. Let's see. So now we can actually put stuff at the load. Which... How do I want to do this? You know, I'll just use a lot of connectors. I'm fine with that. Yeah, we're just gonna use 2 connectors out. Okay, battery's done charging. Just gonna use 2 connectors out for the, ESCs. And... let me get a matching pair of them. Oop. I hope I have matching pairs. I have to unsolder one, but yeah, I do. Okay. Ooh, I've never done this before. What if I, like, stack them together while soldering them? No, that's stupid. Okay. Let me make sure they're, like, facing the same direction. Cool. Alright. So we're just gonna make a little power squid here. We have plenty of space to do that also. Not worried at all. So that's 1. And that is 2. Wait. Oh no, it has to be longer. Where did the robot go? Yeah. So that one's gonna be heading inside of there. So yeah, let's actually make that one longer. Alright. Strip that, and strip that, and strip that, and strip that. Twist those, twist those. Okay, and so let's wait a sec. Okay, yeah, that is negative. Alright, negative. I might as well tin those. Yeah, I probably should tin those. That's like kind of shitty, but whatever. I am too lazy to do. Fuck, I'll just do the clip properly. And how hot is that? That's not hot right now. It's only a little warm. Okay. I guess I can just put that on directly. Yeah, that'll work. Okay. Flip this over. Let's tin this one. Let's clean up that tip because it's nasty right now. Okay. Cool. Tin that a bit. Okay. That looks good. Get this out of the way before I flip it over with the wire. And then, where's the other one? Just had the other, oh, it's in here already. Okay, cool. So let's just tin these ones properly and put the heat shrink on them afterwards. I'm gonna see if I can actually scoot these trackers, which are on my wrists, up to my elbows instead, because they are getting quite in the way. So let's get them as close to my elbows as I can. Might need to get the ones, because I think these are meant to like go on your wrists and not up to your elbows. So like, yeah, I might need to get the ones that like, I don't know. Oh no, I made some custom ones that are bigger, so I should probably try that instead. But yeah, okay, cool. All right, that's more room. Cool. Yeah, let's keep soldering these. Okay, and so the squarish end is positive. Ooh, that one went in nice. And then this end is it's kind of awkward. Let's flip it over. Okay, so that's there. And let's heat shrink that. Let's also... Wait, did I do it right? No, it's the other one. No, not that one. There it is. Okay, yeah, it's not perfect, but this tracker mounting situation's a bit better, at least. 2 and 3. Okay. Alright, let's heat this up. And then you can strip these and twist them and then put them aside, because we also have to do the, what's it called? We have to do the, buck converters also. Those ones are going to be easier because they're not going to require the, what's it called? They're not going to require the, XC30s, as well just directly connect to them. Twisty, twisty. Twisty. Twist. Okay. And then we can start just tuning. So this is already set for 5 volts apparently. I'm not sure if... Because this one it looks like that I soldered it, and then I unsoldered it for some reason, so I'll just have to check if, like, why I unsoldered that, if it's because it wasn't working. And then this one looks like it's vanilla. What about you? This one also looks pretty vanilla. So yeah, we'll just see if this is already 5 volts out of the box, and if it is, then that makes life easier. Where's my red and black? There. No, actually, I want to use the thinner wire. Let's go get that. Thinner wire. Yeah. And, I'm actually gonna use orange and yellow, I think, to denote the other voltages. So yeah, red's just gonna be the full 3S, or maybe you want to bump up to 4S, I don't know. And then, gonna have, I guess orange for, what's it called? 8.5-ish volts. Oh wait, no, we do want that. Okay. I'm gonna use yellow for 5 volts, if that makes sense. I think it does. One thing I'm not too big of a fan with these, what's it called? With these converters is that they have like only one pad for ground instead of like 2, so you have to like do some weird twisty shit. Which is kind of annoying. But yeah, so one of these converters is gonna go to the servo, and the other one's gonna go to the ESP32. And it's important that we give them the appropriate power that they need, or else we'll blow them up, and that's obviously not productive. Hope that this is not too fat to fit in those. It might be. We'll figure that out. Let's see. Okay. Let's twist these together and then solder them, and hopefully they will fit. So yeah, I was mentioning I've been talking about these buck converters. I haven't said what they actually are. There's actually lots of names for things that can convert the voltage, input and output, and yeah, some of y'all in the robot combat world probably call them the BECs or the BECs. I don't know if anyone actually pronounces it that way. That's how I read it anyway. But yeah, those are also called like buck converters. I think they're called like step-down converters also. There's lots of names for them. Voltage regulator might be one of them. Okay, I definitely want to tin that before shoving that in. It's actually one of those cases where it's actually a little easier to put on a bit of soldering paste, because it's like super duper thin and it's not like globby or anything, so it can really help when putting the wires that are already at like basically the limit into like some pretty tight spots. Like, this is almost in, but like there's this little bump here that like have to either just melt it off or cut it off or something. I mean, might as well just cut it off because we're not going to have that whole length sticking out anyway. But yeah, there's lots of names for those, I guess. I don't really see BEC being used outside of like RC and like drone and robot combat and stuff, though. I think that's kind of just a name that's mostly just within that community. And, well, buck converter, you don't really see that being used for, like, when you're going up in voltage. When you're going up in voltage, it's usually called, like, a boost converter. But, yeah, okay, that's soldered. Cool. And then let's do the other one. And also twist that. I might just cut some of those strands out because we don't need all of it, because it's not really that high current, and it's just almost barely too thick to insert. Yeah, this part of the stream is actually taking longer than I expected it to, so, you know, I might actually just do only the PlayStation 3 part in this stream, and then make a second stream on a Thursday where we do the PS3 or the PS4 and the PS5 controllers. Because I do have work tomorrow, so I can't stay up like too late. Okay, so that's also ground. Cool. And let's actually shorten this, because it's way too long. I think it's just easier, though, when you have, like, a longer lead to put into the pad or into the through hole, and then just, like, chop that off instead of, like, try to deal with something that's too short, but now this is actually kind of too short. Okay, I barely got it in. The OmniFixo is, like, the best helping hands I've ever used, like, period. Like, a lot of them, they just, like, don't stay in place, or they break or they stay loose or something, and these have just stayed rock solid the whole entire time. I wonder if OmniFixo sponsors videos and channels, because that would be really cool. Okay, let's get the power connect this. And yeah, I think I definitely want to tin these, because if they're, like, splitting off, then that's definitely short. Since, like, these power leads are, like, right next to each other. Alright. Yeah. Cool. So, in. And that is, again, too long. Need to shorten that. What's the easiest way to do it? I think if I just set up like that and have it kind of like diagonal-ish. Just let me confirm. In is that one. Yeah. Yeah, okay, that's the way to do that. Cool. Alright. Yeah. Huh. Hold on. It's a little suspicious. There's like, okay, no, that's just grease, I think. But I saw a burn mark on this. It's like, maybe that's why it was desoldered, but if it didn't work, why did I put it back in the box? Okay, cool. Alright, so that's all soldered up, and now we can just put the squid together, and then we can test the output voltages to make sure that's all nice and damp. Oh wait, forgot, I need the output voltage wired up. That's right. Okay, so orange is going to be for the almost 9 volts. I think it was like, what, 8.4 volts? And yellow is going to be for the ESP32's power, which is 5 volts, I think. I should probably confirm that, but I think it's 5 volts. Yeah, it's 5 volts, because we can take USB power directly in, and it's just going to regulate it on its own. It's important, though, that you don't want to power the servo for, like, Robot Combat stuff, I guess, off of, like, microcontrollers, voltage out, because, like, yeah, it's gonna be 5 volts or whatever you need, if you want to do, like, something as low as, like, 5 volts, but, like, at the same time, those regulators usually aren't meant for that kind of current that we use in Robot Combat stuff. I mean, it might work for, like, an ant, but I definitely wouldn't do it for, like, a beetle. Okay. Yeah, this will have to be trimmed also, but at least it is tinned. Alright, so does this have, yeah, that's the one with the 5 volt blob ready, so we'll just put that to there. Oh, let me just confirm that's the correct one. Because we want voltage. Oh, no, that was the wrong one. Okay, I'm glad I checked that. Yeah, my schedule is gonna be pretty crazy because, like, so this weekend is actually kind of one more normal one because I'm just gonna be in San Antonio for like one day with my family for Thanksgiving. And then I'll be back at home on Sunday. And I think I'm gonna do like my MIDI piano keyboard stream teardown at that time. But yeah, my what's it called? My schedule. So I guess I'm probably gonna have to split this stream into 2 streams actually. And do probably the PS4 and PS5 controller half. Which at least we aren't gonna be rewiring everything. We're just the only thing we're gonna have to wire is just like the ESP32 S3 or C3, whatever we use. But yeah. Next, so this Saturday I'm gonna be doing Thanksgiving stuff. Friday, which I don't stream on Fridays or Saturdays, it's gonna be the big Texas A&M versus UT football game. Aggies are undefeated, and I went to Texas A&M. I actually didn't really care that much about football until I went to Texas A&M, and now I actually care about it a lot. And we're undefeated this year. There's only 3, I think, undefeated teams left, which are Ohio State and Indiana and Texas A&M, which all are currently AP ranked 1, 2, and 3. I believe that UT Austin, the Wicked Longhorns, are at like, I think they're at 8 and 3. I only hate them in football. They're a really good school. Like, both schools are really good. But when it comes to football, I hate them. But what's it called? Yeah, they're I think they're 8 and 3. But if they beat us, dropped it, then we lose our bye in the COD football playoffs, I think. And we also lose our perfect season. And I want the perfect season because that's very rare. And I was also in Kyle Field during the final game before the whole SEC realignment and Longhorn Network drama and whatever. And I watched us lose in like the last few seconds during, I think, some like crazy field goal kick or touchdown at the end. And I also watched last year's game, which was the first match between the two before, after everything kind of realigned back together and we lost. So I really, really, really hope that we win this one. But this time the game is played in Austin instead of in College Station. So, yeah, they have the home field advantage. And they weren't doing too great at the beginning of the season, but now they're objectively doing pretty well. So it's gonna be tough. All of the analysts say that's like basically a 50-50 toss-up. But yeah, let's see. What? How did I just do? I think I just autopiloted. I have no idea what I just did. Where is the other converter? Okay, it's there. Oh, I guess I just tinned those. That's good. Okay, so we're gonna make the wire squid. Just going to twist all of those together and then link them up to the batteries, and then we can actually get the output voltages of these things and tweak or replace them as we need to, and then we can actually hook it up to the ESP32 and start to get programming, which... How long has the stream been going? Almost 2 hours. Wow, that's wild. Okay. So, order of operations. How do I want to do this? I think just really just twisting all this. I mean, this actually might be a good case for the WAGO connectors, but I don't know where those are at right now. Oh well, whatever. I spent way too long in the stream looking for random stuff. Okay. Just keep twisting these on. And then I think for that like really long lead that's up to the battery and the switch, that'll just be twisted through on the other way, and then I hope that I have some appropriate thickness of heat shrink for this. Or, you know, actually, since it's going the other way, I think it actually makes sense that, like, 3 of them go one way, and then 2 of them go the other way. Yeah, let's do that. But I think at this point I'm gonna tin these a little bit at least. Maybe not all the way, so it's not like super thick, but like I don't want them to undo each other. So I'll just like do like a partial tin here. I think a full tin. I don't know if this is the correct way to do it. I'm not a professional at this. Professional coder, not a professional whatever this is. Okay, these are going to be some pretty longish leads. Let's see. Okay, let's twist these ones. Woohoo, twisting stuff. We love twisting wires. Do we love twisting wires? Maybe we do. Don't know. And I think I'm gonna do the same thing where I like just kind of tin it a little bit so it doesn't unravel at the base, but don't want to tin it yet so I can actually still keep twisting it around. Or, sorry, I meant don't want to tin the whole thing yet so I can still at least twist it around the other side. I actually don't really know how to twist wires very well. Like, it sounds like it's easy to do, but I feel like there's kind of an art to it, which despite doing this hobby like for as long as I have, for like what, probably 6 or 7 years regularly now, still haven't really mastered it, so I should probably look up how to do that. Okay, heat shrink. We're really close to being done wiring. Yeah, I would not be surprised if we actually have to use, like, almost all that length, to be honest, or, I don't know. I think we can get away with, like, maybe just 2/3 of it or so. Okay. So we have that. And, yeah, this is gonna be a little messy, but it could have been worse. I'm glad I didn't tin the entire thing, just a portion of it. Okay. Let's solder this up. This is really ugly, but what wire squid is not ugly? Well, it's gonna be warm for a while. And then this one, and try not to touch the probably still burning hot joint there. Wait, did I put... Oh, I didn't put it on. That's kind of important. Let's slip that on. Okay. It's not the cleanest, but whatever. Okay. Whee! I think I want to also, let's see. I've been thinking of, like, what other content I want to make, and I think that it makes sense for me to, like, take some of these, like, streams and, like, because I've been already, like, clipping a bunch of shorts out of them. I think maybe, like, okay, that's really, like, I'm just flip this over and, like, do the other side's worth of joints on that. But yeah, I've been thinking of, like, what else I want to do on my channel, and I think that, like, taking some of these, like, guide-ish streams and, like, turning them to, like, edited longs. Yeah, that's what I think they're calling them now, because, like, if you have, like, the shorts, like the TikTok-ish kind of stuff, or the Reels kind of stuff, apparently they're calling the normal length, or I guess what classic YouTube was when it wasn't streaming and wasn't shorts, they're calling them longs now, I guess. Not YouTube, but, like, content creators and stuff. So yeah, I've been wanting to, like, maybe make some longs, I guess. out of these, but I also wonder if maybe it's better just to, like, kind of do proper takes for those instead of, like, just one long-ass stream. But then again, when you're, like, kind of filming, like, projects and stuff, it can be easy to, like, forget filming stuff, and you're like, oh no, I forgot to do this. But if you're doing, like, a long stream, then, like, you just have the whole thing kind of there ready. So, I don't know. Kind of thinking about that. At the same time, something with, like, the longer form editing is, sometimes I get, like, kind of hesitant about, like, oh no, I'm not sure if I edited it well, but, like, when it comes to streams, it's like, oh, it's already being just kind of eated out there already without it being perfect. It's just already there. Just kind of the way it is already. And so, guess that's another reason why I think I'm starting to like streaming more, in that, you just do it in one take, and whatever happens, happens. Okay. Now, that's done, and, think of what to do here, because, like, it's kind of exposed, and it being exposed is a little sus. Let's see, my good electrical tape is, like, packed somewhere in the depths of hell, so I'm just gonna use this, like, kind of crappy electrical tape, but whatever. I'm just gonna go wrap one of them electrical tape. And then the other one, we'll just check the output of that. This feels like a good time for me to actually have a smoke stopper. Don't have one right now. Oh well. Okay. So I'm just gonna tape these leads up so that they don't short on anything, because that would be tragic. And then this. Let's see. Where is... oh, here it is. Just gonna pre-close that. And then take a battery and hope I don't blow myself up. And if I blow myself up, then I'm totally clipping this. But also probably getting scalding burns all over myself. And then... okay, that doesn't sound like anything bad happened. Alright. Multimeter. Let's see if you're getting 5 volts out. If you're getting 5 volts out, then we can hook you straight up to the ESP32. Hell yeah, that's 5 volts. Perfect. Okay, cool. Unplug that. And I'm just gonna tape over that a bit. And then the other one, we want that at, like, 8.4, I think, volts. It says it on the side of the servo. Okay, so we know that one's good. Let's just wrap that one up, because it's currently completely exposed. Should probably get my hot glue gun started up too. Okay, so that is wrapped up and nice and safe. And I'm gonna go plug in the hot glue gun also. Hot glue gun. And then where is... there it is. Okay, so this one is gonna be kind of weird because it's like adjustable. And it's probably not going to be the right thing right off the bat. And I'm also going to... what am I going to do? Because I can't just hold the leads on there at the same time. I might actually go get my other multimeter, which I have alligator clips for. Yeah, let me go get that. Okay, so alligator clips, where are you? Oh wait, I don't need to get the whole ass thing, I can just take the alligator clips themselves off. Oh wait, what's that? Oh, I didn't know I had that. Okay, it's... Screw it, I'll just get the, I'll just get those. Plus it has a bigger screen so you can actually see it from the viewer view, I guess. Okay. Plug that into there. Plug that into there. Let's turn that light on in case that helps. Does that help? Yeah, that does. Okay, cool. And it's not glaring right now. At least I don't think it is. Okay, we have these alligator clip ones. Ugh. They actually don't stay in. Hold on. You know, I actually have like so many soldering connectors that maybe I'll just like directly solder these on. And not really. No, you know what? I'll just wrap them around. That's okay. Just wrap and tape. You don't need to overthink this. That's the wrong side. Yeah, let's just wrap that and tape it. And maybe clip it with the OmniFixo also. Okay, so that's there. Wait, I just... whatever, I'll just read backwards. It doesn't matter that it's, like, the reverse polarity here. Okay. So yeah, it's just gonna read the voltage backwards. I don't think that matters. Oh, this is also on AC instead of DC. Now we're on DC. Okay, cool. So, I need to unwrap this converter, wherever the tape starts and ends or whatever. And then we're gonna go... Oop. Nope, that didn't rip anything out. Okay, cool. So this one is... We actually have like a little tiny screwdriver here so we can adjust it. And we can also set up little solder blobs here to like just set one of the fixed voltages. So that's pretty convenient, I guess. Okay, so if we plug this in, we are already immediately at almost nothing, which is kind of, you know, I wonder if maybe the fact it is backwards is an issue. Wait, that just means I can just like switch these. Yeah, let's see if that works. Okay, that's concerningly low, honestly. Okay, no, okay, it's because it wasn't a good connection, but now it's clamped back in. That's at 12 volts, which is too high. It's actually kind of weird, because it's almost like it's being completely passed through. So, where'd my screwdriver go? Precision screwdriver kit, where did you go? There. So I'll see if spinning that does anything, and if it doesn't, something's wrong. But let's see, we're at 12 volts right now. Okay, yeah, this is also not the right size. It's too small. Get a slightly thicker bit for that. Did that change at all? I don't think that actually changed anything. Oh no, that's too big. Huh. Okay, that's actually really weird. Okay, so it looks like if I'm touching it on the back or something, then it's actually not spinning it either. Okay, that one's too big, but the other's too small. We'll just try one of the random flathead ones. Okay, that's actually changing it. Alright, yeah, this is actually what we want. We're at 7 volts. Okay, we're at 8 volts. 8.4 volts. That is exactly where we want to be. And let me just make sure that... Okay, that's kind of the correct side. If I unplug it... Yeah. Oh, my hot glue gun just fell. Anyway, need more sticks. Okay, cool. So I want to glue this on here just so that we don't change the value of that. And then I'm just gonna hit this with the upside down freeze bullshit. Cool. Okay, so we have the correct voltage coming out of that now. Cool. So we have power for the ESP32, the servo, and the, what's it called? The two drive motors. Or I guess the ESCs into the drive motors. And with that, I'm gonna go take a bathroom break. So I'll see y'all in maybe 5-ish minutes. Let's see. Pause. Alright, I am back. Let's see. I need to fix the cameras. Not that camera, not that camera. Is it this camera? No. Hold on. Why is it not switching over to the, Wait. Okay, it says webcam. So why is it not going to the webcam view? There we go. Okay, cool. Alright, we are back. And what was I doing? I was soldering... Oh, I just finished testing out the, power stuff. And this blob of hot glue is definitely cold now, because I just touched it, and we have proven that it's cold. Okay. So, now you can actually hook this up to the ESP32. That kind of took forever, but okay. Yeah. So, thankfully, this is super easy. We literally just solder these two things in. Although, I do want to just double check that we're at 5 volts, because I think this is the only one that I have right now of this size of ESP32. And if I blow it up, then this, yeah, stream's not gonna be so fun. So yeah, let me just confirm that this is supposed to get 5, that this is 5 volts. Yeah, that's 5 volts, that'll work. Cool. Okay. Unplug that. If it wants to unplug, I don't want to let that go or else it'll short. Okay, cool. So, pin out. So, I don't know if that's actually like just a normal VN or, because I mean that one's like clearly whatever that is. Well, I don't even think this has like a 5 volt, right? I think that's just like 5 volts in. But yeah, let's just solder that up. Although, how many ground connections do we have on here? Do we need that many grounds? We don't actually, because yeah, we don't actually need more ground than just that, because yeah, we're already gonna have ground for the signal coming in from like the, what's it called? Ground for the signal is already gonna be coming in through the power source leads. And we're not supplying any power directly to the servo, we're just sending a signal to it also. So yeah, that'll work. Yeah. So we're just gonna hook this up, and hopefully it should do a thing. That did not touch anything of value. Oh, why is this cold? Okay, 2 questions. Why is that cold, and how did that solder that anyway while it was cold? Okay, well, that's in now. Maybe it didn't actually, and it's just an optical illusion. Alright. So that's in, and then let's just make sure that if we power it on, we see like some LEDs turning on, I guess. That was backwards. Okay, yeah, that's powering on just fine, and I didn't realize it had a NeoPixel built in. That's cool. Yeah, you can see this little RGB LED here is just cycling through. Okay, cool. Oh. Probably should not have had those just dangling out there. Okay, so I think the first thing we're going to do actually is just get a servo controlled with the ESP32. And let's see, so where is this big fat servo here? Here it is. Do I want to bother with proper connectors? I might as well. Okay. So, servo, let's make that purple wire. Let's make the signal for the servo purple. And let's have it at like maybe the maximum length that can possibly be from ESP32. And I'm going to tin that, but I'm not actually going to solder it to the ESP32, because there's a weird quirk with the ESP32, and that is certain pins are not friendly for servos, or I guess anything that's like analog PWM, while other ones are. So I don't want to do that yet while we haven't figured that out. And let me go get my connectors so that we can crimp this. Ooh, it's all the way in the back! Okay. Just need 3. There's no space, so I'm just gonna open this stuff here. 1, 2. What is this? Huh. Why does it have backwards pins? That's not my problem. I mean, it is actually gonna be my problem later, but not right now. Okay. Okay. Let's crimp those wires. Yeah. Actually, those should not be tinned then. So I need to chop that off. And also, it doesn't need to be that long either. At least it's just the tip. Okay. Oh, it could also be twisted too. Keep dropping this. Okay. So we're gonna crimp these pins on. And I completely forgot what the correct thickness is for this. We will figure that out. By just seeing if this actually goes in or not. And stays in. And if it does, then this is correct. If it doesn't, then I fucked it up. And I'll just grab my weird, kind of crappy, but at least they're like kind of automatic-ish crimpers. Yeah, that works. Okay, that's cool. So that's ground, and then the middle is gonna be voltage. And then the other side is a signal. So yes, that's like the second to last one, and then the last one. Second to last here. Oh yeah, this is gripping nicely. And then grip. And that'll go in the middle. And just kind of do an assisted pull through. Unless I didn't grip it enough, then might need to redo that. No, that snapped in. Cool. And then signal wire. Doop, 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 doop. Oh wait, did I twist that? I don't think I twisted that. Or, you know, that's actually... that's the end that I, tinned. Take that. And then twist that end. And then... let's do that. And let's crimp it. And it's kind of stuck for some reason, because I engaged that lever for some reason. And then we can stick that in. Pull through. Cool. And then we can connect that to a servo. And might just want to tape that just to keep it in place with my cheap Daiso electrical tape. And then we will look up which pins on this ESP32 can actually do servo output. Yeah, so all I need to do is just figure out which pin is actually okay for that servo wire, and I guess for the other ones. So we can actually go back to look at the computer view. Hold on. Okay. Computer view. Computer. Reorganize the desk a little. Everything is super messy. Okay. So yeah, this is what we're using right now. And let me just see if PWM, oh, I can use PWM output on any pin. Okay. So what is PWM? PWM is, I think that's pulse width modulation. Misspelled that. And so it's basically like having a square wave, except that like the output, we have different proportions of like what's high and what's low. And so this is actually a really good chart here. So 0% duty cycle, we have basically none of it is high 25, we have a quarter of it is high 50, we have 50% of it's high 75, we have like 3/4 of it is high, and 100% it's just full send. And so PWM, it's used for lots of things. We can use it to control LED brightness, we can use it to control like brush motor speed, and so it's better than like changing the voltage of stuff, where instead of having like just the raw voltage is like, let's say that it's like 0 to 5 volts. Instead of it being like 2.5 volts for 50%, we're actually just sending pulses of 0 and 5 volts, where it averages out to 0 to 2.5 volts. And so it's because like things like LEDs and some motors and stuff, they need like a minimum amount of power to actually like be turned on. If you just send like a fraction of it, then it doesn't work. But like if you send it in like slices, then you can simulate having like half speed or like half brightness or something. And so PWM, we're also using that for servos and for speed controllers to send throttle. So basically if it reads out like, oh, we're high 100% of the time and we're low 0% of the time, that's full throttle. If we're high half the time and we're low half the time, then that's 50% throttle. And so yeah, we can use that to control motors directly. We can use that to control speed controller throttles. We can use that to control LED brightnesses. We can control lots of stuff with that. And servos, you also send a PWM signal to tell it where it should go, if it should be like all the way this way, or if it should be like all the way that way or something. Yeah. And so with that, we can use any pin we want, actually. If I'm checking that correctly, which means that they chose the good pins. And so that makes things a lot easier. So yeah, let's just choose the first pin then. Let's go with AO. Analog 0. Which we can actually do digital stuff on that one also. Just that not all of the pinouts can use can like take in analog values. Is this like a fucked up tinning shape? I think it is. I'll just cut it off and redo it. Well, the core of it's, or I guess the end of it's probably good, so I just need to like do that and twist it. Yeah, exactly. Okay, cool. So I just need to solder that, and then we can actually start programming. Ish. Yeah. I'm gonna make that a bit longer. Okay, let's solder that. And let's turn off the solder sucker and the light since it's just really annoying to look at. Alright, cool. So, I need to find like a really long USB cable, I think, so that I can actually like show this stuff on here while it's being programmed. Let me find like a servo horn. Maybe, where's one of the weirder shaped? Here's a weirder shaped one. So we can actually see what's going on here. Oh wait, why is it stuck on that screen? Hold on. I thought I had auto camera set up. There we go, we do have auto cameras back on. Okay, cool. Yeah, so, I was just looking for a servo horn for this. Yeah, I'm gonna go just plug in the battery again, just make sure it didn't, like, blow up. That's not good. Oh, wait, shit. Wait a second, what's going on here? Okay, so... yeah, this is the correct thing for that. So why are you not turning on? And I didn't use one of the ones that was, like, not insulated. Okay. Now it's working. I don't know what happened there. But let me go find a USB cable that is long enough so that I can actually demonstrate this stuff live. Oh, wait. Oh! You know, that could actually work. I have my VR tether cable. I can just, like, probably use that directly in there. Let's see if that works. If it makes the doo-doop sound, then I think it'll work. Let me loosen that cable a bit. It works! Perfect! Okay, cool. Alright, so... that screen is not as cool as if I just show, like, the workbench. So I'm just gonna show the workbench for now. While setting up the IDE. If the workbench wants to cooperate. Okay, that's weird. It wants to go one way, but not the other way, but whatever, we figured it out. Okay, so, let's open Sea Lion. That's my ID for programming this stuff. Well, you know, actually, I probably should just, well, I don't know. I don't want to actually do that right now. Yeah, we can just set this up at first. Okay, fuck it. Y'all can already figure out what my first name is if you look deep enough, so I don't even care at this point. Okay, so, yeah, we want to, let's just call this PS3, example. And, platform IO. We want to put it on the, ESP32. Actually, let's see if, does Adafruit have their own? They do have their own, so it actually might be better. Yeah, let's do that. So, yeah, so I'm not using the default Arduino IDE. I'm using, Sea Lion, which is made by JetBrains. I just really like, their Rider, IDE, which is used for, like, C#. And so I also use Sea Lion and PyCharm whenever I need to do, like, C++ or, Python projects. And so this is gonna be in C and C++. And so Platform IO is a, it's an extension, it's actually, yeah, it's a lot of stuff, but one thing it is also is an extension for lots of IDEs, such as Sea Lion, so that you can, do microcontroller development, right out of it. And normally, if you have like just a typical ESP32, like this one, then we would be picking like let me just make sure it's on the right one. Yeah, then we'd just be picking one of the Expressif, I guess, dev board configs. But Adafruit actually has their own specific one for, let me just confirm what this one is. This is the Cutie Pie. Oh, that's cute. The Cutie Pie ESP32 Pico. So we can go to here, Cutie Pie ESP32. Let me just, I know, because that one doesn't say Pico on it, so let me just ensure that's like the only one that exists that is not like an S3 or C3 or something. To have anything that's not in this form factor, although I'd imagine that everything would be in that form factor. I do also love that it's like purple. So that does look correct. So yeah, let's just create that project, PS3 example, which I'll post links to this, by the way, wherever in the description, I guess, at the end of this, and upload it somewhere or something. Let's have it in a new window, I guess. Close out the old one. Cool. And it's gonna take a bit of time to set this up. Let's see. I also just want to make sure that like nothing is exposed and will be shorted or something. But yeah, and then I could probably be like silly and just like tape something to that, or hot glue something to the servo horn so that we can actually see it move around. Let's try to find like a really bright object. Bright object. Let's go with this Sharpie. We'll just super glue that a little bit onto there. Okay, cool. So when we get this working, we should see it spin left and right. That's kind of the goal. And let me move this cable over so I can stop hitting it with my hip tracker. And then yeah, so we have this. Let's just make sure it uploads with the default settings. And I like to put this duty right here instead. So yeah, we're just uploading this default code template to it. Whee! It looks like that worked. And then, let's see, we can't really verify anything other than it uploaded. So let's just go to the examples and see if they have like a thing for just like I mean, ideally, if they had an example for, do we need examples anyway? We don't need examples. Okay, let's just, include servo.h. Do you exist? Please exist. No, it doesn't exist. Okay. Okay, we need to find a servo library then for this. Oh, that's right, because the default Arduino ESP30 or the default Arduino servo library doesn't work on the ESP32. So we have to find this. But the good thing is that I've already found this ages ago on my GitHub somewhere. So let me go find that. Let me change the camera real quick. Okay. GitHub. Data collector firmware. Platform IO. ESP32 servo library. Okay, ESP32 servo library. GitHub. Platform IO. Yeah, the original one that I wrote, it used, what's it called? The IDs for the, platform IO, I guess, registry, but just the raw ID numbers. I don't know how to search for that, like... Platform IO registry. Okay, I'll just put this, like, another window right now. But, okay, let's see. Let's just switch back to the normal thing. Okay, so Sea Lion. We're going to go to here, and we're going to add lib deps. That is library dependencies. We want Arduino, and we want whatever the heck this one is. That is from the previous project. And let's see if we build that, if that'll actually pull that. Unless it's like out of date, and we don't want to do that. Okay, it's ESP32 servo. Okay, so we did find that correct library. Just wondering if we can find the actual repo for that, because then it's not black magic and it's like actually a thing. But it's 3.0.9, so we could probably actually just like track that down just by searching for that. Oh wait, what the... Okay, so it's probably whatever this library is here. Yeah, 3.0.9. And it looks like that says that this is not out of date. So I guess that's good, because the one that I was looking at before said it was out of date. And then... yeah, so all we want to do is, okay, I just don't like brackets when they're there. So we want to define lifter servo pin at A0, because that is where we soldered it to on here. We soldered the that servo pin to there. Let me set this back up. And it is safe if we just leave this battery plugged in also. Yeah. Oh wait, what? Oh no, that's okay, because we got rid of the original program from that. Cool. Okay, so that's good. And so let me go find, where's that library? I'm just gonna split screen this so that we can look at examples of how it's set up. Okay, examples. Yeah, let's do a sweep. Okay, so sweep, that's just gonna be like, we're gonna have it go all the way one direction, and then we're gonna wait, and then we're gonna have it go the other direction, and then just wait. And so we're going to find that one servo, that one servo pin, and we want to define include what? ESP32 servo.h. I probably have to like clean this and reinit for it to actually see that. Let me just check my other code to make sure that it's kind of matching that. Yeah. Might be tools, platform IO. Reload, actually, I think, instead of reinit. There we go. Okay, cool. Yeah, that's kind of one of the more annoying bits about using Sea Lion, is that it doesn't do this stuff automatically as well. You'll probably have a bit of an easier time using VS Code with platform IO instead of using Sea Lion, but I already am kind of invested in the JetBrains ecosystem, so I'm going to use Sea Lion I mean, the code's gonna be pretty much the same, and the platform IO config is gonna be pretty much the same. The only different, like, this is really just kind of different from the Arduino IDE, which, like, does everything in a .eno file, and just kind of does things in a weird way. I'm not a big fan of the, I guess, the kind of, like, Arduino paradigm compared to, like, kind of the proper way to do this stuff, but anyway, that's a whole different rant. Okay, so we're gonna define a servo. It's gonna be lifter servo. And so, let's see. It looks like that we want to have int lift. What's the, okay, I'm just gonna use the normal code cell that I guess I use for, nah, fuck it, wait, maybe, no, okay, whatever. Lifter servo position. I just like to spell out everything fully. And then, I guess that we need to allocate timers here for some reason. No, not that. Okay. SP32, PWM, allocate timer. So, I think that that means that we're going to be allocating one of the PWM peripherals on the SP32. It's not as simple as it is with, what's it called, the Arduino servos, and I don't know why, but that's just the way it is. And then, let's see, lifter servo dot set period hertz 50. I think that's just the standard. Why is that? Oh, misspelled hertz. And then we're going to attach the lifter servo. And attaching is actually kind of important for here because this is what arms a servo basically. And like, so we want to attach and detach when we do the failsafe stuff, but we're not going to do this failsafe stuff right now because that's coming on a bit later. Okay. So how do they do it here? I don't like the way that they're, well, do I like the way that they're doing here? What do you think about it? Okay, screw it. We'll just follow their example. Okay, for... It's just kind of a weird way to do it. Okay, whatever. For, lifter servo... I don't like that way. How would I do it? Thinking. Oh, you can't even see the code because I'm in front of it. Okay, I guess I'll go move the example code to that side, and then move this here, and then let's kind of pull that over until I'm not in the way. Actually, I'll just do it their way. Okay, for... Nope, I'm not gonna do it their way. Int I is equal to... I is smaller than 180, and then I plus plus. Yeah, I just thought it was weird that they kind of reused that variable in the for loop. I don't think I've seen that pattern before. That's just kind of weird. But yeah, we'll just have it so is equal to 1, or is equal to I, and then we're gonna write that to that, and then we're just gonna delay. I want to define float servo sweep period. Let's say that that's we'll just make that like 5 seconds. And then delay. So that's gonna be like 180. Servo sweep period divided by. Let's also define int min position is equal to 0, int max position is equal to 180. Min position and max position divided by math. Oh wait, I have to include math. Include. Wait, was it math? That's the correct one. Is it maybe math.h? I'm just kind of used to the way to do it in C#. What was I doing? Okay. Delay that by, oh yeah, ABS. Is it math.abs? Okay, I have to look it up. Okay. Absolute value in C++. Oh, it's in okay, it's an STD, I guess. Okay, include CMath, I guess, and include CST. It's been a while since I did C++, so I'm being a little slow right now. STD-ABS. There we go. Okay. Min position minus max position. And let me just think if that's correct. Okay, so 0, so that's always going to return 180 if it's negative 180 or 180. And then it's going to be 5, so that slices it into whatever that is. Yeah, that sounds about right. And then we're going to sweep it back. Or I guess, no, we're not. No, I is equal to max position. And then I is over min position, and then I minus. Equal to I, lifter servo, da-da-da. And then, yeah, that looks about right. And it doesn't matter if that's flipped around because it's, what's it called? It's, absolute valued. Why is it wiggled to underloads? Why is it wiggling to underline stuff? That'll probably work. Okay, let's upload that and see if it actually sweeps. And if it sweeps, then we should see that, Sharpie move back and forth. And then that's part 1 of this. We have the output working. Well, it's kind of working. It's a little sussy, but okay, maybe I'll just copy the example code and not try to be a hipster. Okay, example code, let's copy you. Except let's just reuse the same variables. And then it's not my servo, it's lifter servo. And then we have that. Okay, let's see if that works. Okay, well that works. My code didn't work. But this does. And we are sweeping a little more than 180, but that's expected because servos are kind of weird. But yeah, we have that working. And now let's actually do the PlayStation part of this. You know what? It's actually really, really annoying listening to this, so I'm just gonna comment this out, and then I'm going to upload it so that I don't have to unplug it for it to stop, but it's gonna stop. Alright, cool. Now, where is that ESP30... not ESP32. Well, yeah, I guess ESP32 PlayStation 3 library that I found ages ago. And then let's include that. ESP32 servo library. No, not ESP32. ESP32 PlayStation 3 controller library. Yeah, it's the JV Pernis library. And I forgot how to include that. How to include a GitHub thing in the platform IO. Cleared as a dependency in that. Okay, so I guess I just put it straight into here. Oh wait, I can't make that all the way there because I'm in the way. Okay, cool. Let's see. Oh, it's responsive. Well, of course responsive. It's GitHub. It'd be weird if it wasn't. Oh, wait. Okay, we're installing that library. So this is... I'm actually going to post the links in here anyway. So this is the PS3 controller lib. And, let me see, what was that other one? ESP32 servo. 3.0.9. Okay. And I'll update the description of the stream with that. But yeah, I remember there's like a weird step with this though. And we're reading it here. When the PS3 controller is paired to a PS3 console, it just means that stored the console's thing in there. Okay, so we're just gonna be... You need to figure out what the MAC address is of the figure out the MAC address is of the PS3 that it's connected to, which it's not because I haven't used my PS3 in like a decade. Or change the MAC address stored in the PS3 controller. Whichever path you choose, you're going to need a tool to read and write the currently paired thing, and there's a thing called 6-axis pair tool. You can also use 6-axis pairer if open source is important to you. But either way, we need to so there's kind of two ways of thinking about this, and this is like kind of the quirk of like the older PlayStation 3 way of doing things before Bluetooth controllers and gamepads and whatever were standardized on the PC. So, what does that mean? What does that actually mean for us? It means that we're gonna have to make the PS3 controller talk to specific MAC address, and we're gonna have to set the ESP32 to a different MAC address. Or we can figure out what the ESP32's MAC address is, and we can set the PS3 controller to that. But I think that the way of just setting the ESP32 to a specific MAC address and just setting all the PS3 controllers we plan to use to that MAC address is the cleaner way to do this, because it means that you can just you can switch out those ESP32s like as spare parts without having to like repair the not repair as in fix, but repair as in pair again the PS3 controller to the different ESP32 controllers, to the microcontrollers. But yeah, so yeah, I think, and let me just go through my old code to make sure that's what I did here. Okay, I'll just show my old code here. So yeah, what we're looking at right now is the old code for a data collector. And we're not going to be using this much code for this example at all. We're very much going to be using something a lot simpler. It's not going to be as smart, but it's going to be simpler at least. Okay, where's just, if you just search Mac. Formula, oh yeah, so the formula ID bullshit that was for, Okay, I'll just look for pink when I'm scrolling through this. So we're gonna ignore that because that's how I was doing like voltage calculations specific to the ADC. You know, maybe it's not actually in here. What if it's in here? I thought I had these all set up to set the MAC address of the ESP32 to like the same thing based off the code. Oh, you know what? If you figure out how to cheese this to interfere with my controls, you are both smart and an asshole. Okay, cool. But yeah, it looks like that's how I, figured out stuff, I guess, with that. So what does that mean, though? Because I guess that's gonna be initialize controller. Oh, I see. Okay, so that's actually the... Okay, so hold on. Go back here. PS3.begin. That means PS3 controller begin talking to something that wants to find that IP address, I guess? Or not IP. Is that an IP address still? No, it's MAC address. Oops. Close enough. I mean, they're not the same thing, but they're similar, I guess. They're not really that similar, but whatever. Okay, so it looks like that's actually the same thing that's, like, on this extremely faded out label that's on the PS3 controller, which you can barely see. So yeah, we're just going to, I guess... Well, I want to explain what I'm doing, though. So, let me see what that is. What the hell is this? Okay, it looks like that was... Okay, I tried to click on this, Dancing Pixel Studios. Link from... Okay, that's weird. Open link in new tab. It looks like they don't exist anymore, so let's use the other tool that is linked to it. 6-axis pairing tool. Okay, I don't actually want to do this. Okay, so we're just gonna go kind of blindly off... Okay, no, I should actually probably explain it the proper way. Okay, so... The two tools that... Oh wait, actually it may just be hosted on a different website now. Okay, 6-axis pairing tool. Let's see if you still exist. That looks like a really, really sussy link. These look really, really sus. I don't trust those links. Okay, are you a real person? Hope you're a real person. Yeah, you have enough karma. You are still active? Okay, I trust you to not be posting a sussy link. We're gonna take a chance on this one. So 6-axis pair tool. Can I comment on him? Okay, I'll just... Yeah. I found this link 7 years later, after the original link died, and I see your Reddit account is still active, so I'll take a chance on hoping your link is not sussy. Yeah, let's do that. I mean, if it turns out I'm installing a virus, then this will just be clippable material. Okay, 6-axis pair tool. Oh, it's not even plugged in. Okay, I have to plug in the controller. I think I have to plug in the controller anyway. Alright, so... At least I think that's how it's used. Okay, so... Want to connect it to that? Let me plug in this adapter into the PS3 controller thing, and we're going to temporarily unplug this. And it is warm, but not burning hot, so I'll take that as a good sign. And we will do this. Plug that in. Hopefully I'm tripping the camera so they can see. Yeah. Oh no, it's not working. Okay. Let me just change it manually. Why is that not working anymore? Okay, that should be working now. Okay, cool. So the PS3 controller is there. Okay, no, I don't want to restart my computer because that means I have to end the stream. And I can't do that. Oh gosh, installation can take time. Installation can take up to 5 minutes. Okay. Do not anticipate this happening. You may be asked to reboot. That sounds like bullshit. I'm not gonna do that. I don't even have to reboot like most of the time I actually do this stuff, so you can suck it. Yeah. Oh, I guess it worked still. Maybe. Maybe I have to press the PS button. I don't know. Let's try that. Oh, it's because the battery doesn't even exist. Oh, shit. Oh, okay, wait. You know, that actually might actually work. Does this actually work? Okay, I don't want to mess with this further, but... So the whole point of the tool is that it just shows you what MAC address the PS3 controller is looking for. And I can't restart the stream right now, because... Or I can't restart my computer, because if I do that, then it'll restart the stream. So we're just gonna pretend that it worked, and we got the IP address. And if it did, then things should work, I guess. That barely made any sense, but whatever. Okay, so, yeah, we'll just do this. Okay, so... And it looks like we didn't even use those libraries. Alright, so let's include... What is the library we're including? PS3 controller.h. And we probably have to do that one thing that I talked about again. Tools, platform IO, reload the project. Okay, it's reloaded. And so, let's go look for the examples on this. Examples. Okay, this looks like it's the simplest one. And so, yeah, that looks about right. So, if the controller is connected, we'll say connected. And we need to set up serial.begin. I'm gonna set it to that default nice fast speed. Looks like that's a static one, and we'll just set it to whatever the back of the controller says, / whatever my code says it is too. PS3.begin. So that's the MAC address of that. ready. Okay, so let's see if this works. And let's set up that servo again up here, which is like hanging on for dear life, which while this uploads, I'll just reglue that. While also hitting that with freeze ray. Okay, cool. Alright, let's upload in monitor, actually. Okay, we are writing this stuff. I took my Crocs off for some reason. Where's my other one? There it is. Okay. So, I guess we're waiting for a signal or something. Actually, let me change this code a bit. Okay. Else serial.println not connected. Okay, let's upload that instead. And then we'll just see a big spam that says not connected until we're connected, which should happen when you press the PlayStation button. Oh, you know what? We probably don't actually have the, probably don't actually have that monitor speed set up correctly. Monitor speed. Alright, setting that up right now. Writing. We're trying to get, like, just a bunch of spam that says not connected as soon as this thing is done uploading. Waiting for download. Okay, what if we just stop that? What does that mean? Waiting for download. I'm not sure if I want to do coding streams because, like, a lot of it is like, does this work? No, it doesn't work. Does this work? No, it doesn't work. Does this work? No, it doesn't work. What does that mean? I don't think I've seen that before. Oh, wait. Is it just waiting for me to, like, press a button? One of these ones? Okay, cool. Okay, cool. So we are connected. That's good. It's not going to do anything because you haven't actually coded any of that yet. But we see that spamming connected, and I just had to press that one button for it to work. But what happens if I, like, turn this off? It should start to say not connected, I guess, maybe. Well, actually, no, I don't know if it's going to do that. I don't think that's actually going to do that. I think I figured that out with, like, some fail-safe stuff a while ago. Why am I not showing up on screen? Oh, it's because I'm, like, too far to the side. Oh, and the camera's also not on automatic. Okay, we're on automatic again. There we go. So, yeah, I guess the disconnect is not working. Let's reset it. Okay, so it says not connected. And then here, when I push the PlayStation button, then it should start to say connected at some point. Oh, no, I turned it off. Okay. Okay, so now it's back on. but let's push the button and start connecting, and then it should start to spam connected very soon. There, connected. Cool, so now we know that's working. Alright, now we want to actually control the servo position with that. So let's go to the examples just to see how we can get the just so we can see how to get the what's it called, the let's say just the analog stick data. PS3 event. How does this work? Okay. So yeah, if we are connected, we'll say connected. If we're not connected, okay. Then we just return. We don't care about the player LEDs. We do care about the D-pad, though. Okay, so let's see. Void notify if ps3.event. Let's have it set to the right analog stick Y. If wait, we don't even need to do that, I don't think. You could probably just see what this is. Or no, not that. Just this. ps3.data.analog.stick.ry. Well, yeah, let's just print that out and see what that does. Print line. Let's see what value that is. Okay, we're uploading. You can turn off the PlayStation 3 controller. Yeah, I'm gonna do the PS4 and PS5 controller stuff in a part 2 video on Sunday, or not Sunday, on Thursday, I guess. Okay, I just realized that my avatar looks like that I'm doing something really sussy, but I'm just like scratching something itchy that's like on my hip, not on my down there. Let's reset that. Ready? Did that do a thing? I'm not sure if that did a thing, but whatever. Okay, let's see if that actually, like, does a thing. Okay, so if we move this... Okay, so when we move this back and forth, we can see that we are getting, these values are changing. And that's exactly what we want. It's going from 127 to negative 128, and we want to convert that to servo values, which we'll have that at 0 to 180. And I believe that there's like a map function also. So let me look up how that works. Arduino map. Okay, so analog stick goes, I'm just taking notes here. Okay, so what's from low, from high, to low, to high? Okay, so let's do lifter servo position is equal to, is it map? Yeah, that's how it works, I guess. Map. Actually, first let's do auto. RY position is equal to ps3.data.analog.stick.ry and then let's do map. No, that's not the right order. Yeah, that is the right order, actually. No, that's not. Okay, these two are bullshit, though. Min position, max position. Let's actually rename that to min servo position. Oh, wait, what the fuck is going on? Min lifter servo position. And max lifter servo position. And let's also have int min stick position is equal to -128, and int not that, it's actually 127. Yeah. Okay, cool. And so let's have this go from, wait, no, that's actually the wrong order. Okay, the from position should actually be min stick position, max stick position, and then min, yeah. Okay, cool. Also, the autocomplete is just, fucking, what's it called? Copilot. Yeah, and let's just have it delay, I don't know, like maybe, 10. That's gonna have it run at, like, 100 hertz. Now, it's actually kind of overkill, because, for running at, 50 hertz, yeah, then that's twice as fast, actually, so just have it delay at, like, 20 hertz, I guess. Maybe? I don't know. That could work. Okay, so when we upload this, I'm expecting it that whenever we move the stick, up and down, the right stick up and down, then you should have that servo moving up and down. And if we can, then that's great. Woo! Yeah, I guess I have to, like, press the reset button every time I do that. What happens if I press the other one? Okay, it'll probably work, though. So what happens here? Will this work? It doesn't work! We are getting the values broadcasted, though. And it is printing that. Oh, duh, I know what's going on. We forgot to actually set the servo position. So actually, let's also, hold on, I actually forgot, how do we, have it output? Okay. What was the equivalent of... You know what? No, that's the wrong one. Do I have the Copilot? Okay, whatever. You know what? I'm just going to, we're just gonna do ChatGPT. Okay, so you know how in C# I can do this? $, poo, variable 1, pp, variable 2. Yeah. How did she know that I wanted to do it in C++? For Gore out to do it in C++, please help me. No, come back to me, little Rizzler. Let me unforgore you. Okay. Yeah, sure, let's just do that. Does it actually know what that is? No, it probably doesn't. Okay, we're just gonna do it the ancient way, which I assume that this is doing. said I wasn't going to, vibe code, but now I am. Oop. Oh, well. Poo-poo. And, where's PP? Okay, you know, I should probably, no, fuck it. Because where am I mapping that at? Servo lifter position. Okay, cool. So, I actually don't want to call it that. Yeah, let's do that. Add comma. And then I guess serial print line result. This feels really dirty, but whatever. I didn't like that. What's the string though? Oh wait. I think I'm getting tripped up in the bullshit string and string bullshit. How did you know I was tired? I mean, she knows time zones now and stuff, I guess. Arduino serial.println. Do I have to like format as a C string or something? I do. Okay, well, this isn't like a super important part of the coding. I'm just debugging. String dot result dot. Yeah, I'm normally into like C# a lot more than like C++. So yeah, I'm kind of being tripped up right now. But yeah, I just want to get more. Oh, what the hell? Bruh. How is it that big already? It should not be that big. What the hell? Is string stream really that big? Okay, you know what? We don't need it. We don't need to debug that shit. We're just gonna write the servo stuff, which means I'm not using ChatG's suggestion. Okay. Writing stuff. But I seriously want to know, is stream chunky? We somehow used up all the flash them already. What the fuck? Oh. S-Stream is mega chunky on Arduino, like Skibbity Doomslayer size. It's one of the biggest flash eaters in the entire STL. Wow. Okay, I'm glad I erased that. Now, let's actually test this shit. Yeah! Yeah! Works! Woohoo! Whee! 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 Okay, yeah, that works. Alright, well, we can't really fail-safe servo stuff, though. That way, though. Why can't we fail-safe servo stuff? Because it doesn't really spin continuously. Okay, so cool, that works. What next? We're going to do the drive, but that requires a bit more soldering. So let's do some soldering. Yeah, we're making it on time. I wanted a longer stream than usual. I'm gonna disconnect this motor, and we're gonna This is going to take a bit of a while, so we're going to let it charge, or not disconnect the motor, disconnect the battery. So we're going to let it charge for a bit. 2.7, yeah. Oh wow, this thing is like almost fully charged already still. So yeah, we're going to, oh wow, that's a little toasty for some reason. Okay, so we're going to disconnect this, and we're gonna fix those ESCs. Let's see. So, I'm vaguely remembering the color scheme that I did with these ESCs. And, yeah. So, this should be pretty good already. I'm not gonna mess with that, but, I am going to, change the... Oh, you know what? I don't actually need to change that much. I just need to disconnect this and just change these to like XC30s. So yeah, it's actually pretty simple. I'm not gonna spend that much time soldering. Can't find my flush. Oh wait. Oh, here are the flush cutters. Okay, cool. So cut that off. Yeah. Cut this off. And so all we're gonna do is we're just gonna put XC30 power on here, and then we're gonna strip these, and we're just gonna plug it directly in to the ESP32. Yeah, that sounds about right. And we're also going to hope that the ESCs still work, because I don't think I've touched these ESCs for like 3 years. Okay, so let's get these tinned. And let's turn that on, and so we'll go sideways, because we learned that turning it sideways is pretty poggers. Now let's clean that tip, just the tip. Insert the tip. Just the tip. I think that the air is circulating weird because I have my fan going, my Vornado, because it's really, really hot. Okay, we got that tinned. And... oh, we need to extend one of the wires, though, if it's going to be on the other side. But that's okay and easy to do. Okay, and the XT30s, when I have to like undo the shit on, just cut off that what's it called, that old heat shrink, and then let's just heat this up, and let's take the tweezers and let's just pull off this bullshit. I don't really know what's the best way to do this. We'll figure it out, though. Oh, that was easy. Okay, cool. Yeah, that works. And then the other one's virgin. Let's take some heat shrink wrap. Heat shrink, where are you? There you are. Is this heat shrink even like thick enough to go, or I guess wide enough to go around? I'm not sure. Oh no, I lost it! Can I see it? If I can't see it, I won't waste my time looking for it. I can't see it. I'll just cut another. And let's also tin this. then the other side. And then start to solder it. Okay. So, let's see. Positive. Nice. Okay. And negative. Okay, that's nice. And I'm gonna wait for that to cool down before actually doing the heat shrink wrap. And then, where's the other one? There it is. I'll rotate that around. It's a little loose. It's not great when it's loose, because then I worry about the integrity of the connector. But that's okay. And we need to put some heat shrink wrap on that too. Snip, snip, snip. We are snipping the heat shrink. Okay. Let's see. Oh, we're charged. Nice. Unplug that. Oop, that fell. So that's a little closer. Okay, so top is negative, so we will start soldering that. Woof! That's spicy hot. On the other side. That is not stable, so we will reinforce it with another OmniFixer thing. There we go. That's good. Solder that on. Is that good? I'm not sure if that's good. Probably could use a bit more solder. Yeah, that's looking good. Okay. Let's undo that. And it looks like the first one. Let's see, it looks like my hot air thing is still active. Probably give it another couple hours or so. Doop, 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 doop. Let's give it 4 hours. Okay, so I'm gonna heat shrink this. And then the other one. Can heat shrink it too. Alright. Cool. Alright, and so if we need to, I don't want to mess with the firmware on these, especially since like AIM32 is dead. So if something's wrong, we'll just flip the phase wires. I'm pretty sure that those are all set up for a drive motor. Yeah. So let's say that this drive ESC lives in here. And like the what's it called? The power is already set up for there to reach all the way there, but the signal is not. So we need to extend the signal wire. Extend, I mean replace. So how long is that? Let's say that's gonna be about this long entirely. Oh no, it should be red. No, I don't want to use red because we're already using that for power. So if blue is left, let's see, let's just use white for right, I guess, because those words sound close enough to each other. Or, you know, if I actually use the very thin gauge stuff, then it's pretty clear it's a signal wire, so let's actually do that. Let's stick with the normal convention that blue is left and red is right, because red starts with R. And let's overshoot that, because if it's too long, you can just trim it. And then blue, not you, you're too thick. Thicker than a bowl of oatmeal. Yeah. Yeah, that should be long enough. Where did you go, anyway? I need to figure out where to source, like, super thin purple wires, though. Okay. So, actually, these are, like, so thin, like, can you literally just strip them by pulling them off if they're silicone? That's a little handy. But yeah, let's replace the signal wires on these DSCs then. Oop. Alright, so let's secure this one here. And let's also tin the ends of these ones, just so they're a lot easier to solder on. Woo! That is smoky. And let's trim that because those pads are really tiny. Okay. Let's get rid of this white wire. And let's install this blue one. And so blue is left and red is right. And let's do the same here. Make it a little perpendicular so that they're like it's not sliding around too easily. And then let's get does not feel secure. There, that feels secure to me. Okay, cool. Alright. Cool. It's got that, and it doesn't matter which pins we even use for I guess stuff. So, yeah. Already have this set up, but I'm gonna disconnect it just so that doesn't cause any more ruckus. And okay, so that's okay, so we're removing the servo with its silly Sharpie thing. And then taking this stuff, I'm gonna put some tape on there just so that it's not too exposed. Where's some tape? Here's some tape. Because shorting stuff usually results in a bad time. Let's just use this scrap piece. It's just temporary. Okay. So yeah, long boy here is gonna be for the right one. And the other one is gonna be for the left one. Cool. And so let's just set left to the next one and then right to the last one. Let's keep it nice and easy. Okay, so let's clip this one, and then let's pull and tin this one. Something just fell. I don't know what fell, but something did. Then we're gonna tin these. Something sounds like burning rubber again. It's better than smelling burnt toast, because at least that means you're not getting a stroke. Okay. I forgot the order, but whatever, I'll just reference it later. Okay, so I'm gonna insert this into A1, like the steak sauce. Yeah, I've learned how to make steaks really good, to the point that it doesn't need sauce, but like at the same time, A1 steak sauce is nostalgic to me that I don't mind the taste of it, but my steaks don't need A1, at least. That's good. That should got kind of pushed in. Okay, there we go. Alright, that signal wire is good. Then A2. Let's get you into... Let's stabilize this on the USB port. And then let's get you bricked up. Okay, there, cool. I was like, did I accidentally plug up that pad with some solder, some stray solder? But I guess I did not, which is good. Okay, that's lined up. Everything's plugged in. And we'll know if things are set to like default or whatever. Okay, so this is gonna be a bit more complicated than the servo stuff, because ESCs have to do an arming sequence, which I believe because these ESCs are set to drive, that means that they're waiting for a neutral, which is 90 degrees. So we have to have them start at 90 degrees for like maybe like 1 second or so, 1,000 milliseconds. And you want to hear them do the thing also. So yeah. So first, I'm gonna go raise this up here, and you can't hear the doo-doo-doo-doops without the motors actually doing a thing. So then you plugged in, which thankfully everything's already kind of pre-wired for that. So left is blue, right is red. And if we're doing this properly, I may have to rearrange things so they can actually see everything that you need to see in view. Let's toss this away, I wouldn't need you anymore. And where's the Omnifixo? Omnifixo was here. Okay, so let's see, how do I want to set this up so that nothing shorts? I think I'm gonna have it so this hangs out in the air there. This hangs out in the air here. Yeah. And then, let's see. We will have this. I don't think we actually need to solder any more things to the ESP32. So for now, we can just insulate it with some tape and clip it. Yeah, that should be Gucci. And then what else? We now have the battery just kind of hang out somewhere, but we definitely need a LiPo battery to get these brushless drives going. Let's see, we also need to make sure that actually works, and I believe that when the ESCs are powered on, even if they're not getting a signal, then we should hear like some doo-doo-doo-doops at least first. So I'm gonna unplug that side so that we don't get confused with what we're hearing. Okay, so this ESC should at least be partially working because we heard doo-doo-doop! And let me actually get my second microphone out so they can hear that. And fun fact, the sound does not come from the ESC. The sound actually comes from the brushless motor, because they figured out how to use brushless motors as speakers. Okay, so that's working. Let's try out the other side. Unplug this one, and plug in this one. And then plug in the battery, and we should hear doo-doop if it works. It works. Okay, cool. Yeah, I don't think that anything actually works if you don't hear those doo-doo-doops. If you don't hear the doo-doo-doops, then nothing should work. Alright, so that's good. Now, despite the fact that these are ESCs instead of servos, we're going to treat them as ESCs. Because they still take PWM input, and I haven't set them to be like, we're really going to take, it's got D-shot, or whatever. No, they're not too good for that. They're still going to take, good old PWM. So, yeah. That means that we set up servo drive left, servo, actually let's call it ESC. Servo drive right ESC. Let's have int arming position for drive ESC, so that at 90 degrees. And so for here, we're gonna set up, let's see, ESP32 PWM, okay, timer 1. We're gonna have drive, I don't know why that's being auto-corrected to 50. And then we're gonna attach it also drive left ESC dot attach. We didn't set the pins for that, so let's define those pins. Define, what's it called? Drive ESC pin. Drive left ESC pin, that is. Okay, so drive left, that's gonna be blue, drive right is red. So blue, you are... Okay, so blue is A2, and, or right is... Sorry, left is A2 and right is A1. Left is A2, right is A1. So left is A2. Right is A1. So we're gonna attach that to that. And then we're gonna define the other one. ESP32, PWM allocate timer 2. Cool. So we're also gonna add in the setup that drive left ESC dot right. We're gonna set it to the arming position for drive ESC, which is 90 degrees, I think. And then we're going to wait. What's the wait thing? Delay. I'm gonna assume it's like, let's make it a bit higher than 1 second. 1.1 seconds. And so, ideally, when I upload this, then let me go plug in the thing again. Ideally, when this is uploaded, then we should hear the ESCs both turn on and then arm. And let's see. I don't think we need to actually monitor stuff anymore, so let's erase that and let's upload. See how this does. This might work. Uploading. Uploading. Oh no. Why is it not happy? Why does port 6 not exist? Okay, let's try. Oh, you know, it's probably because I had the clip on the, what's it called? On one of the buttons. Let's try again. Upload. Cannot open COM6. Port does not exist. Okay, well that's frustrating. Why is this not working? Because it was working before. Let's try again. Okay, I forgot how to do this. Let me ask her again. How do I check which ports are open to upload to and manually set them in Platform.io? Platform.io. I just read it as Platform.io, but I know it's actually Platform.io. Okay. PO device list. That's a lot of things. Let's see. I mean, we could just try a bunch of different ports. Okay, let's see what ports do we have? Yeah, COM 6, 4, 3, 5, 13, and 14. Let's try COM 4, maybe. Okay. Upload port is equal to COM 4. Let's try that. I'm not sure if I like that. Connecting. You know, it actually could also be that the battery's unplugged too. I have a feeling it's not that. Okay, let's erase the upload port. Let's kill that. Oh, you know, actually, now I think about it, the monitor port could have actually just been on the whole time, which I know makes it angry sometimes. So yeah, just unplug. 1 alligator, 2 alligator, 3 alligator, 4 alligator, 5 alligator. Okay, cool. Let's plug the battery in, because I know that sometimes it helps for some reason. Okay. Upload. Whee! Oh, it's working. Cool. Woo! Okay. Awesome! We heard the doo-doo-doops! Doops! Doops! So that means it's working, or at least it's arming. Now, so this is gonna be like super simple. Like, this is not a really logical way to drive the robot stuff, but this is a good way to test it at least. Okay, so auto left position, left drive throttle. Let's just make that data.analog analog stick.lx auto is gonna be ly, yeah. Or no, sorry, right drive throttle is gonna be ly. And so we're gonna have and we don't even need to like have this stuff here because we can just like write it directly now. We're just gonna have left, or no, sorry, drive left ESC dot right left drive throttle, okay, right drive throttle, and that might be viable just for testing at least. So once the controller is connected, then we should have the wheels spinning once we start messing with the left drive thing. And at the same time, I'm gonna go pee while this uploads. So that's okay. Okay. I'll be back in like a minute. So I'll wash my hands. Totally forgotten to switch to the pause thing. Oh wow. Anyway, we are uploaded and I'm back. Wait. Are my hands working? Oh no. My right hand is gone. Let's reconnect that. Okay, we're good now. Alright, so let's see if this works. Does that work? Okay, so let's reconnect the servo at least to make sure the servo is working. Right now the drive does not seem to be working, so we should figure that out. Servo is working then. Okay, so servo is working. The drive is not working. Let's go. Okay. Let's see. Oh, we never mapped stuff. Okay, that makes sense now. Okay, so, let's see. Int min drive ESC position is equal to 0 because those operate in the same way, and max is that. And stick positions are going to be the same for both of them. Let's also have, so I was wrong, we're actually kind of saving that. Okay, so int left drive ESC throttle is equal to 0. Right drive ESC throttle. Actually, I want to rename that because I like to put drive first before the position, because position is secondary to the purpose. Drive right ESC throttle. Okay, cool. Alright, so drive left ESC throttle is equal to map. Drive left throttle. Min stick position. Max stick position. Min drive. Okay, cool. And we're gonna do the exact same for drive right ESC throttle is equal to map. Right drive throttle. Right drive throttle. Min stick position. Max stick position. Okay, cool. And then we're gonna actually set those to that. Try to make sense because it was going to like super wacky values. Cool. Let's upload that. Writing the memory of the program. Okay. So we're hearing it doo-doo-doop just fine. It's a good thing. Let's see if this actually works. If not, then we're gonna have some debug logs. Oh, okay. We're getting something. Okay, that's interesting. We are getting... What? Okay, this is really... Okay, this is interesting, because we are getting stuff out the left and right. So it looks like the neutral values are not working correctly. And we have some pretty extreme things, but in general, when we do move this up and down, when this is moved up and down, we are modulating the left side drive to an extent. And here, when we move left and right, we are changing that too. But the values are all weird and wrong. And so what I actually want to do is I want to move the lifter away from this and to one of these. And then we can move the left side drive to this and the right side drive to this. But right now it's... I'd say that these sides are promising because we are like... we're at least controlling the motors in some way. Just the values are being mapped really, really weird. So we can fix that, at least. Let's see. It's probably better if we consolidate the order of the stuff too. But yeah, so let me consult the example code and see where we're going with PS3 stuff. Okay, so the first thing I want to do is I want to remap the lifter servo to okay, so left drive, let's remap that, or let's keep that at, or let's remap that to LY. And let's set right drive to RY. And then look at the example code for what the trigger buttons are, but on analog instead of digital. Digital, not you. Digital D-pad, not you. Digital shoulder, not you. Digital trigger, not you. Analog stick. Analog D-pad. There we go. Left shoulder, left trigger, right trigger. Okay, cool. So let's set it to this. Let's get rid of that big ass void of stuff. And let's rename this to lifter throttle. And at the same time, let's also just set some debug logs. Okay, that's pretty clutch. Whatever you're called. Actually, let's do some commas here instead. Copilot, that's you. Okay. Alright. We hear the doo-doo-doops. That's good. Let's connect the PS3 controller. Things are still not working. Oh. That's weird. Okay, I mixed something up here. For some reason, the right trigger is controlling the right wheel, and the left stick is controlling the left wheel, and then this is still controlling the lifter. I mean, just pretend this is the lifter here. So I clearly got something mixed up. Okay, lifter throttle. Oh yeah, I totally did get that mixed up. Let me copy pasta that. Yeah. Okay, cool. Let's re-upload. Okay. Hopefully that should make sense now. Where did the controller go? There it is. Alright. Connect. So I think we need to like set some dead zones. Don't know why that is like so much slower and this is like super crazy fast. But at least this is working-ish, I guess. Let's, you know what, let's just be silly and just, have that here and just hot glue that on. Yeah, let's do that. Hot glue gun is, dead. Okay, so let's... So at least this is, like, doing its thing here. But for some reason, this is like operating super slow. What the heck? And things are like disconnecting left and right. What? Okay, I don't actually get what's going on. I guess that neutral is like really fucked up right now, and so you need to set like trim probably. in some way. Or at least we need to, like, debug what the heck the neutral value is right now. Because I feel like that its neutral value is, like, really messed up right now. And at the same time, I wonder if there's, like, different ESC settings going on here. And I also wonder if, you know, actually, I think I know what's going on, possibly. Should the servos go from 0 to 180, or from... Wait a second. Let's... Okay, so what if we set that to like 30, and then whatever, 30 minus, okay, 150. And then let's also upload a monitor to see what these values are. See if neutrality is not what we think it is. Also, I don't think we're gonna get to the fail-safe part of the stream. I think we're gonna save that text stream. Right now, we're just kind of hello worlding stuff right now. But yeah, let's just get this shit connected. And see what's going on. Okay, so we should probably set like a dead zone here. I didn't imagine that we need to set dead zones already, but I guess we do. But I also think that these ESCs are either set to different settings, or the right ESC might be dying or something, because like clearly the one on the left has a lot more vigor than the one on the right. But it also might just mean that I need to find matching ESCs before the next stream. Yeah, this is definitely a two-parter stream. This is not gonna be all solved in the same stream. Life is just not that easy. But yeah, let's set some dead zones here, I guess. Plus whatever that servo bullshit is here. Oh, okay, that makes sense too. Okay, and it also looks like that the servo, or not the servo, the lifter throttle is not mapped the same as the triggers. So serial.print lifter trigger raw. We need to add quotes around that. Is going to be not that, but this. And we're also going to just make that a comma. It's not doing what I expected to do. Okay. Yeah. So, let me also mess with the dead zones. Okay, so it looks like 89-ish, 88-ish. Okay, so it looks like that the right throttle is kind of going properly where it should be going. And it also looks like my theory of changing the throttle min and max is not correct. So we can revert that back to 0 and to 180. And let's set int ABS dead zone to, let's make it 5. Sure, 5. Alright. So let's see. Okay, if ABS left drive throttle is smaller than, what the fuck are you suggesting? That's some bullshit. ABS dead zone, then let's just make left drive throttle is equal to 0. Let's do the same thing for right. And then we'll also be able to see the values of what the lifter throttle actually is once it's set to the right trigger. Bless me. Okay, let's see what's going on here. You're writing some values down, and then, okay, waiting for download. I guess that we're gonna spam those buttons because I forgot what they do. Then we're gonna press this. Yes, we're connected. Okay. Still left trigger while 0. Let's push all the way. It is 255. So that means that those are actually really different. So it means that, int min, trigger position is equal to 0, and int max 255, thank you. Which means that we can map lifter throttle min stick, min trigger, min max trigger. Cool. And we also have the dead zones figured out. What the heck is going on? Like super slow now though. It's really weird. Okay, I wonder. Okay, so my current suspicion right now, because like if I go from 0 to blank, then it's like struggling. But if I go and I speed up slowly, then it's good. And if I so what I'm thinking is that these two ESCs either have different settings, or this one is good and this one's bad. Also, I'm thinking that we could, oh shit, we should probably add like a capacitor for like voltage spikes too. You know, I think that's what's going on, is that we are having voltage spikes that are resetting something. So we should probably add some caps to that. But also, there's like not parity between the left and the right ESCs, so we need to figure that out too. And also, everything died. Or at least the right side died. But, we can at least figure out the, servo issues though, because, it's pretty easy with, just how the min and max range is not properly set up right now. But yeah, there's actually a good chance that the next stream I'm just gonna replace those two ESCs, which may probably be set up for different settings to some older drive ESCs that I have just kind of laying around. Okay, so waiting for download, and we've got this dupe and that dupe. Oh, this needs to reconnect. Okay, so At least we have our lifter not being weird as heck. Wow. Okay. Okay. I'll take that. I'll take that. I just don't know why that's going the complete opposite of what it should be doing. And when it's at like max speed for too long, it just dies. So you know what? Actually, probably fix. Okay, so the ESP32 is not dying because we know that like it's resetting. The ESC is resetting, but the ESP32 is not. So it probably means that the ESP32 needs some kind of like stabilizing capacitor, but the or not, sorry, the ESC needs a stabilizing capacitor, but not the ESP32. Although adding a stabilizing capacitor is never a bad idea, at least. I do want to know why, though, if we supposedly have a dead zone set for stuff, why the right side is still twitching, because it could mean that the right ESC is just not working the way it should. But yeah, well, okay, so far we have got a PS3 controller here. We have it connected to an ESP32. ESP32 is controlling two ESCs and a servo. The servo is working absolutely perfectly with no issues. The left and the right drive ESCs are slightly working, like they are at least responding to their assigned controls, yet they are not responding the same way. This one has a neutrality issue, and this one's at full throttle in either direction. It neither wants to be slammed either way. It needs to be slowly throttled up, and when we keep it throttled up all the way, then it dies. So we need to figure that out. Yeah. And we're not gonna figure it out tonight, because it's like, what? It's past midnight right now. So, I mean, I've been saying in the past couple hours, this is gonna be a multi-part stream. At least 2 parts. Hopefully only 2 parts, but I would not be surprised if it's 3 parts. But, yeah, we're having some issues here. So yeah, my gut feeling right now is that we have to figure out if the two ESCs here are actually working, and preferentially, I'd rather just find my like known working AM32 drive ESCs that I had in 2FA, because I don't even know if I use these for drive. It's possible that one of these was set up. One of these was set up for weapon, and the other one was set up for drive. And these are also, I believe, BLHeli32, which is a currently unsupported and now dead firmware. So yeah, I guess that's the state of where we're at right now, but I'm kind of kind of nearing the end of the stream, I think. Yeah, but we did make some good progress here, and I do want to wrap this up within 3 streams at least, hopefully by the next one. But yeah, at least we made some progress here, and I think that, yeah, I was hoping I could just take clips from this one and just condense it down into a single long form video that's like a good instruction thing, but I'm not sure if this can happen. But yeah, this is just the process of R&D and trial and error when you're doing robot stuff. Nothing works automatically, nothing works as clean as you want it to be. So yeah, let's see. I know, I think it's time to just unplug the battery and the microcontrollers and kind of call it a day and just yap for another 10 minutes or so. Woo! Yeah, let's just do that. But we made some good progress today. We definitely did a bunch of stuff, at least. Woo! Okay, let me just toss these cables around, because there's so many cables lying around, oh my god! Set it back to office view. Okay, I believe this is working! Yeah! Alright, so yeah, wait, hold on, let me fix this error message. Okay, cool. Yeah, well, okay, so that was what? Let me check, what does OBS say? That was 4.5 hours, which I believe the first 2.5 or 3 hours were just spent soldering instead of actually doing what I was gonna say I was gonna do on the stream, but that's okay. And then, we've been programming for the last at least hour and a half. But yeah, we did not fulfill the stream goals, within tonight, but that's okay, that's just the way that RNG works. And I didn't want to cheat and just use the pre-existing solution. I wanted to kind of go at least semi-organically what the process of actually figuring this stuff is actually like. Because if I wanted to do this cleanly, then I would have just done this is my face track? It is. I would have just done this in just a long and sort of like a stream. But yeah, okay, cool, my magic chair is working. Kind of. Okay, now it works. So yeah, oh, that pose looks weird. Let me fix it at least a bit. Okay, cool, we're good. So yeah, let's see. Yeah, so I guess Thursday, we're just gonna be continuing on this. Sunday, if we have to, we'll keep continuing on this, but Thursday, I do aim to actually wrap this up and do it on PS4 and PS5, because once we have the baseline programming for the PS3 controller, then most things are gonna be mostly the same, it's just gonna be adapting the controls, and that's not too hard. But yeah, tentatively, if we can wrap this all up on Thursday's stream, then Thursday will just be part 2 of the stream, and Sunday will be a dissection of my mechanical MIDI piano keyboard. If not, then Sunday is part 3 and hopefully wrapping things up. But yeah, we at least made tangible progress. You can see that we have the wiring set up, and we're probably not gonna be touching much wiring in the next streams. And now it's just about programming and or making sure that the correct ESCs are in. And if it turns out the current ESCs are wrong or have the wrong settings, I think I'll just be fixing that off stream. But yeah. Alright, well, we're nearing 1 AM Texas time. We are nearing 5 hours on the stream. I think this is actually the longest stream that we've had. So yeah, I think it's time to wrap it up, because I've got work tomorrow, and depending on where you are in the United States, because you are my most likely audience, it is between 1:38 AM to 10:38 PM, and you probably want to go to sleep. So yeah, I think it's time to wrap this up. But yeah, this was a good stream. This is probably the most down and dirty we've gotten. I think this is more dirty than the 3D printer fix stream. So I'm happy about that, because frankly, I've been playing it really safe with these first streams and stuff, and I've been really wanting to get into let's actually start to get kind of risky. Not that kind of risky, but more so like success or fail kind of risky in the streams. Like let's get real instead of like just playing it safe. So yeah, I'm glad that y'all joined and stayed tuned in and watched the stream and watched me derp around, and hope y'all stick around for the next one. Yeah. Alright, my goobers, I think it is time for me to log off. So, yeah. I'll see y'all. Wait. I wanna use my hand gesture technology. Okay, cool. Alright, well, time to log off. Logging off. See you around. Bye-bye. Where is my end the stream button? I'm trying to find the end the stream button. There it is.